To order. Without objection, the chair is authorized to declare recess at any time. Good morning and welcome to today's hearing entitled The State of Climate Science and Why It Matters. Let me first welcome everyone to the full committee hearing of the Committee on Science, Space, and Technology for the 116th Congress. I'm looking forward to a productive and collegial meeting today, one in which rigorous scientific discourse can help enable the creation of a sound public policy. Every committee is meeting because we've had to alter committee meetings this week because we've had 2 funerals. And so we will have members coming and going, and we hope that you'll understand. I also want to welcome all of our distinguished witnesses and thank them for their flexibility in making themselves available to participate in this rescheduled hearing. Today's hearing is the first in what will be multiple climate change-related hearings this Congress. Following the release of the IPCC Special Report on Global Warming of 1.5C and the National Climate Assessment last year, it is clear that we're responsible for our planet warming at an alarming rate. And we already feeling the impacts of this warming today. Setting the stage with the discussion of the most relevant and up-to-date scientific evidence from these and other reports will allow us to better understand the climate-related impacts we're experiencing in all of our districts. The evidence of continued unmitigated emissions of greenhouse gases is clear. Our coastal communities are dealing with sea level rise and ocean acidification. And all communities deal with more severe weather incidences and the increased exposure to extreme heat and poor air quality. Today's discussion on climate science is important to deepening our fundamental understanding of why the climate is changing and how this manifests in ways that impact society. It will also help us as we turn our focus to the role of science and innovative technology development to devise adaptation and mitigation strategies which will have numerous positive benefits for our economy, our safety and security, and our public health. I'm glad we have the leading experts in these fields who work closely on these reports to guide our discussion. I also want to note that the impacts of climate change are not limited to what is described in these climate science reports. Just last week, NOAA's State of Climate Report for 2018 found that it was the wettest year for the contiguous U.S. in the past 35 years. NASA and NOAA also found that last year had the 4th highest global surface temperature since 1880. It has almost become a given that we can expect record-breaking temperatures every year, especially since the past 5 years has been the warmest in modern record. Though this administration has regrettably chosen to ignore the findings of its own scientists in regards to climate change, we as lawmakers have a responsibility to protect the public's interest. I plan to do this by making sure this committee is informed by the most relevant and up-to-date science as we work to conduct our legislative and oversight responsibilities. The Science Committee oversees much of the federal climate research, and as well as the development and demonstration of new and innovative technologies, which makes our role as members of this committee critical to preparing our country to deal with climate change. I look forward to kicking off a fruitful and informative discussion that will continue throughout this Congress on why we need to act on climate change now. Now I will recognize the ranking member's opening statement.
Thank you, Chairwoman Johnson, and I would like to again thank you for holding this hearing and providing a flat platform to hold a constructive dialogue on the issue of climate change. I'm proud to be a Western Oklahoma farmer and to represent a resilient community of farmers. As any farmer can tell you, we are especially dependent on the weather. Droughts, heat waves come and go naturally, but the changing climate has intensified their impacts. We know the climate's changing and that global industrial activity has played a role in this phenomenon. But our communities, like farmers and ranchers in my district, need to know more about the extent to which a changing climate affects short and long-term weather patterns. I believe the federal government has a responsibility to prioritize research so that we can better understand the complex relationship between climate and weather and increase preparedness in our communities. I also believe it's critical that America leads the world in developing the next generation of technologies to address the effects of climate change. Fortunately, we have a unique opportunity here on the Science Committee to promote research and technology solutions. American industry, innovators, and researchers at our national labs are pioneering technologies that capture carbon emissions from coal and natural gas, batteries that store energy from intermittent energy sources like wind and solar, and advanced nuclear reactors that can provide cleaner, more affordable power. These technologies have the potential to reduce greenhouse gas emissions around the world and ensure American energy dominance. America has always led the way in technology advances. In 1919, my great-aunt's prized possession was a phonograph, a mechanical device which was then state-of-the-art technology. 100 years later, we listen to music on our cell phones, and no one could have predicted the incredible leap forward in technology. Americans are always innovating, finding surprising ways to meet new challenges. Energy is no exception. Hydraulic fracking revolutionized energy production, unlocking a vast American energy resource that was unimaginable just a decade ago. Developed by industry in cooperation with the national labs, fracking reduced the environmental footprint of energy production and has brought cheaper, cleaner natural gas to the market around the world. Through innovation, we can repeat this incredible success. The next technological breakthrough is right around the corner. And if we want to succeed, we must continue to focus on realistic, technology-driven solutions to climate change that can compete in today's economy. We won't succeed in pie-in-the-sky policies that demand 100% renewable energy at the expense of reliable power from nuclear and fossil fuels and raise energy prices for businesses and consumers. Today, we'll hear from Dr. Joseph Mica, the Director of Climate Policy for the Niskanen Center, who will stress that it's essential that we take a realistic, innovative, and competitive approach to addressing climate change. I share his belief that by investing in research to develop carbon capture, carbon use, advanced nuclear, and renewable energy technologies, we can incentivize innovation and growth in these industries and reduce carbon emissions in the process. Innovation is good for the global environment and the American economy. I take environmental policy very seriously. This dedication comes from being raised by people who lived through the worst prolonged environmental disaster in American history, the Great Drought and Dust Bowl of the 1930s. We have a responsibility to ensure that events like the Dust Bowl never occur again. While this committee cannot control the weather, we can prioritize investments in basic science and research that will revolutionize the global energy market. America led the world in coal, oil, and gas. Now we must lead again and partner with industry to develop breakthrough energy technologies and make our existing energy sources cleaner and more affordable. I thank our witnesses for being here today, and I yield back the balance of my time, Madam Chairman.
Thank you very much, Mr. Lucas. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our witnesses. Our first witness is Dr. Natalie Mahowald, the Irving Porter Church Professor of Engineering and the Faculty Director for the Environment of the Atkinson Center for a Sustainable Future at Cornell University. Due to the weather-related travel delays, she's joining us through a video link from Ithaca, New York. Her research looks at natural feedbacks in the climate system. And Dr. Mahowald was the lead author on the IPCC special report in 1.5C global warming released last year, and the IPCC fifth assessment from Working Group 1 on the physical science of climate change in 2013. She received her PhD in meteorology from the Massachusetts Institute of Technology, and we now will recognize she'll be our first witness. Our second witness is Dr. Robert Kopp, who is director of Rutgers Institute of Earth, Ocean, and Atmospheric Sciences, and professor in the Department of Earth and Planetary Sciences at Rutgers University. He also serves as co-director of Rutgers Coastal Climate Risk and Resilience Initiative. Dr. Kopp's research focuses on past and future sea level change and the utilization of climate risk information in decision-making. He is the lead author of Volume 1 of the 4th National Climate Assessment, released last year, and the IPCC's 6th Assessment Report, which is due out in 2021. Dr. Kopp received his PhD in geobiology from the California Institute of Technology. Our third witness, Dr. Jennifer Francis, who is a senior scientist at the Woods Hole Research Center. Dr. Francis' research focuses on climate change impacts in the Arctic and how that affects weather around the world, especially how warming Arctic may lead to a weakened jet stream. Dr. Francis is regularly quoted in media outlets. Dr. Francis received her PhD in atmospheric sciences from the University of Washington. Our fourth witness is Dr. Joseph Majkut from the Niskanen Center. He is an expert on climate science and policy and risk and uncertainty analysis for decision-making, and is frequently cited by media outlets on climate scientific research. He received his PhD in atmospheric and oceanic sciences from Princeton University. Our final witness is Dr. Kristie, who is the director of the Center for Health and the Global Environment for Change program and the Rohm Haas Endowed Professor in Public Health Sciences at the University of Washington. Dr. Ibai's research includes estimating current and future health risk of climate change and estimating the health co-benefits of mitigation policies and technologies. Dr. Ibai was the chapter lead on the Human Health chapter of Volume 2 of the 4th National Climate Assessment released last year. She also co-chairs the National Academy's Committee to advise the U.S. Global Change Research Program. Dr. Ibai received her PhD in epidemiology from the University of Michigan. As our witnesses shall know, you will each have 5 minutes for your spoken testimony. Your written testimony will be included in the record of the hearing. When all of you have completed your spoken testimony, we will begin a round of questions. Each member will have 5 minutes to question the panel. And we will start by our witness that is appearing on the screen, Dr. Mahowald. Acknowledge us, we can't. Let's go to Dr. Kopp and then return when we get the technology working.
All right. Well, thank you, Chairwoman Johnson, Ranking Member Lucas, and committee members for inviting me to speak today. My name is Robert Kopp. I'm the director of the Rutgers Institute of Earth, Ocean, and Atmospheric Sciences and a professor at Rutgers University. My research focuses on past and future sea level change and on the interactions between climate change and the economy. I've served as one of the 29 lead authors of the first volume of the 4th National Climate Assessment, and I was invited here to speak to the 4th assessment. I should note that I'm doing so in my personal capacity, not to represent the U.S. Global Change Research Program or Rutgers. The 4th National Climate Assessment provides an up-to-date assessment of the scientific understanding of climate change, its current effects on the United States, and its potential future impacts. It draws out key findings from the massive body of peer-reviewed science to support scientifically informed climate risk management. Its first volume focuses on the physical science, the second on impacts, risks, and adaptation. The report's nearly 2,000 pages are data-driven and extensively referenced. Both volumes underwent detailed, transparent review processes, including open reviews by external experts and the general public, and thorough reviews by independent experts convened by the national academies. The process of drafting the National Climate Assessment was painstaking and complex, but its fundamental findings are simple and urgent. First, climate change is real, it is happening now, and humans are responsible for it. The planet is running a fever. Its average temperature has increased by nearly 2 degrees Fahrenheit since 1900, with humans responsible for essentially all of the warming since 1950. Second, climate change isn't an issue for the distant future. It's already affecting Americans in every region of the country. Across the country, heat waves are becoming more frequent, heavy rainfall more intense, and coastal flooding more common as a result of climate change and sea level rise. Studies show that climate change intensified the dry, hot summer of 2011 in Texas and Oklahoma, the recent drought in California, and the rainfall of Hurricane Harvey in 2017. Third, climate change is not just an environmental challenge. It's an economic challenge, an infrastructure challenge, a public health challenge, and a national security challenge. As the report notes, and I quote, "In the absence of more significant global mitigation efforts, climate change is projected to impose substantial damages on the U.S. economy, human health, and the environment, particularly in scenarios with limited adaptation." Fourth, every additional amount of greenhouse gas emitted makes climate change more severe. In order to stabilize global climate, at any level of warming, human emissions of carbon dioxide must be brought as close to zero as possible, with any continued emission of CO2 balanced by human removal of carbon dioxide from the atmosphere, whether that's by expanding forests or using new, little-tested technologies. In other words, to stabilize the global climate, net global carbon dioxide emissions must be brought to zero. The faster we reduce our emissions, the less severe the effects, and the lower the risk of unwelcome surprises. Fifth, though the pace is not yet adequate to minimize climate risk, Americans are already starting to respond by reducing emissions and beginning to adapt to climate change impacts. As the report notes, 110 cities, several states, and an increasing number of companies have adopted emissions reduction targets. The report highlights adaptation planning efforts by cities and transport systems, the use of innovative farming techniques to deal with wet and dry extremes, and efforts to manage water scarcity in places like the Colorado River Basin and Texas's Edwards Aquifer. These mitigation and adaptation efforts need to grow dramatically and rapidly to effectively manage climate risk. In conclusion, the National Climate Assessment shows that climate change is real, it's here, and we humans are responsible for it. To stabilize the global climate, we need to bring net global greenhouse gas emissions to zero. The sooner we do this, the smaller the risks to our economy, health, infrastructure, and security that we will have to manage. But even with strong emissions reductions, there will still be major adaptation challenges ahead. It's therefore essential that climate change become a routine and integrated part of decision-making at all levels, public and private, federal, state, and local. Thank you for holding this important hearing today. It's my hope that as a science committee, you will look closely at how to advance the climate science enterprise in a manner that supports climate risk management.
Thank you very much, Dr. Kopp. Do we have that ready yet?
I don't think so.
Okay, we'll move to Dr. Francis.
Good morning. My name is Jennifer Francis. I'm an atmospheric scientist at the Woods Hole Research Center in Massachusetts, and I study the connections between climate change and extreme weather. Thank you, Chairwoman Johnson and members of the committee, for the opportunity to testify here today. It's not your imagination. Extreme weather events have become more frequent in recent decades. If we could have figure 1, according to this analysis by Munich Re, one of the foremost reinsurance companies in the world, the occurrence of extreme weather events has nearly tripled since the 1980s. They're shown by the green, blue, and orange bars in this figure. Images of recent extreme weather events are etched into our memories. Neighborhoods flooded by feet of rain unleashed by Hurricanes Harvey and Florence. Docks sitting high and dry in California's reservoirs. and a sunken New Jersey roller coaster in the wake of Superstorm Sandy, to name only a few. Yes, extreme weather has always happened, but there's no question that it's more vicious now, and all the signs point to it getting worse as the globe continues to warm under a thickening blanket of greenhouse gases. Before I go any further, let's clear up a few definitions that sometimes cause confusion. Climate change versus global warming. Climate change means all the ways that the climate system is changing, while global warming is just one of those ways. Climate versus weather. Climate is the average of all the weather that occurs at a particular location, while weather is the day-to-day swings in temperature and precipitation. Think of climate as your personality and weather as your mood on any given day. The links between climate change and extreme weather are a hot topic of scientific research. Some of the connections are straightforward. For example, global warming is making heat waves more intense and persistent, and therefore more deadly. And as the air and oceans warm, evaporation also increases, which fuels an uptick in heavy precipitation events. The warmer oceans are also fueling rapid intensification of tropical storms. And because sea level is higher, storm surges are doing more damage now. On a happier note, though, fewer low temperature records are being broken. All of these changes are clearly tied to a warming planet. Other less straightforward connections are emerging as well. The polar vortex has been in the news a lot lately, so let's start with winter extremes. The polar vortex is a frigid pool of air encircled by strong winds that sits up high above the Arctic only during winter. Recent studies suggest it has been weakening and deforming more often lately, and when that happens, extreme cold and hot temperatures strike the northern hemisphere. If I could have the next figure, please. This map of temperature departures during the recent eastern cold snap demonstrates this clearly. So even though cold records are being broken less often, severe cold spells and heat waves will still happen. Turning southward, global warming appears to be widening the tropics. This may sound like a good thing, but it's causing abnormal heat and drought in temperate regions such as Australia, Southern California, and South Africa. We're also learning that earlier spring snowmelt is causing high-latitude land areas to dry out and warm up faster. This creates land temperature patterns that can trap summer weather systems and make them stagnant. Studies have linked deadly summer heat waves and floods to this change in the climate. Finally, rapid Arctic warming may be favoring weather regimes that exacerbate drought, heat, and wildfires in our western states, while stacking the deck towards cool and stormy conditions in the east. Remember the parade of bomb cyclones that struck the eastern seaboard last winter? This pattern was responsible. In a nutshell, we know that our atmosphere is warmer and wetter, which alters every weather event that happens now. It's relatively easy to determine that climate change made Harvey's rainfall more intense, but it's much harder to say whether Harvey would have stalled over Houston in the absence of climate change. There's no doubt that the Arctic has warmed much faster than elsewhere, but whether Arctic air is surging southward more frequently now because of climate change is a cutting-edge research question. This is just a sampling of the many topics being studied in our universities and research laboratories, the results of which are crucial to understanding climate change impacts, knowledge that will help decision makers and each of us prepare for a future with even more destructive weather extremes. Clearly, more work is needed to confirm or reject these complex relationships, though many are already coming into sharp focus. Thank you again for inviting me to be here.
Thank you, Dr. Francis. Dr. Majkut.
Good morning, and thank you for having me, Chairwoman Johnson, Ranking Member Lucas, members of the committee. My name is Joseph Mica, and I'm the Director of Climate Policy at the Niskanen Center, which is a 501c3 located here in Washington. We work to promote public policy to advance an open society, and particularly in climate, we promote a mainstream understanding of climate science. It's nothing to be afraid of. And we aim to better characterize the risks of climate change. And on the policy side, we support market-based policies to reduce greenhouse gas emissions. The committee asked that we comment on the recent United Nations Intergovernmental Panel on Climate Change's special report on global warming of 1.5C, as well as the fourth National Climate Assessment prepared by the US GRCP. And I'd like to offer a brief summary of those reports. Climate change is real, and global emissions of greenhouse gases are driving latter-day global warming. Manifestations of that warming are increasingly observed, as Dr. Francis just told us in great detail, and attributed to global emissions as well. But these are early days, so many of the changes scientists expect to see are either subtle or undetectable at high confidence. Yet as climate change continues, more severe and perverse effects will manifest themselves, causing economic harms and damages to individuals, ecosystems, and other things that we tend to be concerned about. The science tells us also that limiting climate change means ceasing global emissions, and that's a challenging thing to do. The goals articulated in international agreements, that is limiting warming to 1.5 or 2 degrees C globally, are probably unlikely, given that they would require global emissions to fall by 45 or 25% by 2030 and further from there. That doesn't mean that the impulse to do that is unjustified, given the risks we face. Those emissions reductions, however, sit in stark contrast to what we've seen over the last few decades. To even get close, we'll need significant innovation in low-carbon technology, finance, and market design in order to be able to provide reliable, affordable, and globally accessible low-carbon energy. Given the present circumstance, how should this committee respond this Congress? I've got 3 areas that I think the committee should point its attention to. First, the time to talk about solving climate change is really past us. We're managing a chronic condition, and we cannot place the burden on reducing global emissions alone. Rather, we must prioritize reducing societal vulnerability and adapting to climate change where we can. While this will largely be an effort for the private sector and local government, those efforts will be bolstered by continued federal support for research into climate change's effects and the risks that our communities face. This research can be disseminated through social and professional networks, and devices like the National Climate Assessment provide a very good venue for that work. Second, a world aiming for 2C will require a portfolio of low-carbon energy sources, including carbon capture and storage for fossil fuels. In a world aiming for 1.5C, processes that remove carbon from the atmosphere will need to be deployed at a scale capturing up to 1/4 of today's emissions, and that is a mind-boggling number for an infant technology. Both of these will be large industries, but the technologies are so infant that they need your support. Faster progress is possible through smart investments in advanced research, which deserves the committee's continued attention and support. Third, we have to research alternatives. Last Congress, I testified before your subcommittees on environment and energy on a research and governance agenda for so-called geoengineering technologies, which could sever the link between global emissions and warming. While we had a productive hearing, there's still much that this committee could do to support early research into these technologies and help establish a set of norms under which that research could be done. Thank you for inviting me to testify, and I look forward to a robust discussion.
Thank you very much, Dr. Mica. Dr. Ebi?
Thank you, Chairman Johnson, Ranking Member Lucas, distinguished members of the committee for the opportunity to speak with you today. As you know, my name is Kristie Ebi. I've got more than 20 years' experience.
Research with calm attitudes and not be influenced by news
Do you want me to start over? Sorry about that. The evidence is clear. Climate change is adversely affecting the health of Americans. Climate change is heating the land and oceans, melting snow and ice, increasing the frequency and severity of extreme weather events, and raising sea levels. All of these have significant implications for our health and well-being, as well as for our public health and healthcare infrastructure. It is timely and appropriate for Congress to understand this issue of critical national importance so that effective actions can be taken to protect and promote the health of all Americans, now and in the future. Climate change affects human health by altering exposures to heat waves, floods, droughts, and other extreme events, by increasing the prevalence of some vector, food, and waterborne infectious diseases, by reducing the quality and safety of our air, food, and water, and by worsening our mental health and well-being. Climate change also can affect health by, for example, undermining economic productivity and reducing labor productivity. As a fourth U.S. National Climate Assessment highlights, Americans are already suffering and dying from our changing climate, with primarily negative risks projected to increase with each additional unit of warming. The IPCC special report on global warming of 1.5 C, which assessed research in the U.S. and globally, concluded that lower risks are projected at 1.5 than at 2 for heat-related morbidity and mortality, for ozone mortality if the precursor emissions remain high. Risks from vector-borne diseases such as malaria, dengue fever, and Lyme disease are projected to increase with warming from 1.5 to 2 degrees C, including potential shifts in their geographic range to areas previously unexposed to these diseases. Individuals and communities are differentially exposed to climate-related hazards and disproportionately affected by climate-related health risks. Populations experiencing greater risk include children, older adults, low-income communities, and some communities of color. The adverse health impacts of climate change have many potential economic and social costs, including medical expenses and caregiving services, as well as costs that are harder to quantify, such as those associated with pain, suffering, inconvenience, or reduced enjoyment of leisure activities. Further, our healthcare infrastructure is vulnerable to extreme events, with, for example, many hospitals and healthcare clinics located in coastal regions subject to flooding. The magnitude and pattern of future health risks depend on the rapidity and extent of greenhouse gas emission reductions and on the level of ambition and investment in adaptation. Many projected risks and costs, which in some cases may be extremely unaffordable, can be reduced by taking immediate action to increase preparedness for effectively managing health and healthcare infrastructure risks. Examples include developing early notification and response plans, such as for extreme heat, implementing integrated surveillance of climate-sensitive infectious diseases, and incorporating climate projections into emergency preparedness and disaster risk management initiatives. These steps can protect health now and provide a basis for more effective adaptation to our future climate. Nearly all mitigation policies to reduce greenhouse gas emissions have benefits for health for Americans in the near and in the long term by reducing premature mortality and by avoiding hospitalizations. By the end of the century, thousands of premature deaths could be avoided and hundreds of billions of dollars in health-related economic benefits gained each year under a pathway of lower greenhouse gas emissions. Finally, on a personal note, I grew up in Senator Dingell's district. He was a very dedicated public servant who helped write most of our major environmental and energy laws that were passed by Congress. My condolences to his family, his friends, and his colleagues. Thank you.
Thank you very much. We're going to return now to our first witness. No?
She's not ready yet.
It's not quite ready. Let me thank all of the witnesses. We now will go to our first round of questions. I will go through a few questions I have at the beginning. Last month's government shutdown lasted for 35 days. During that time, many federal science activities were put on hold. While some essential activities continued, like the National Weather Service forecast, many other activities stopped entirely, like updates to NOAA's climate and hurricane models. There were also staffing issues, like the National Center for Environmental Protection, which had just one person out of 200 on staff during the shutdown. These questions are for all of you that would like to respond. First question, what are the short and long-term impacts of a government shutdown on federal climate science? And with the United States currently a global leader in climate science, how do government shutdowns risk the U.S. leadership in producing top climate science, and what impact does it have on the rest of the world? We are heading to another potential shutdown, but hopefully it won't occur. But what are the top risks of our climate science enterprise if another shutdown is a reality? You can start, Dr. Kopp.
Sure. I'll just give a couple quick examples. So during the last shutdown, I was at a IPCC lead author meeting in Vancouver, and there were several of our co-authors who couldn't make it there because of the shutdown. And of course, if you're looking on a large collaboration, having people who not only can't be there, but also can't even be there remotely, sort of makes you an unreliable partner, right? And so if you ask how does this affect U.S. leadership? Well, if we are an unreliable partner in international collaborations, that does make it harder for us to be a leader. Another example, one of my co-authors at NOAA, we were working on a paper together. He didn't have access to his computer or data during the shutdown, and so all the analyses that might have happened during that time were stalled. It's one thing if this is a couple of weeks, but if it's a chronic condition, this really accumulates.
I would just add to what Dr. Kopp has mentioned. There were several major scientific conferences that occurred during the shutdown, and a large number of government employees were just unable to attend and present the research that they'd been working on for literally years, which is a huge detriment to their careers. Also, several field programs that were supposed to occur could not. So in some cases, those field programs maybe won't happen ever, or at least they'll be delayed for a year or more because there's a lot of planning and logistics that have to be lined up to make those field programs work. There was also a big delay in processing proposals for more research or processing reports on that research, and all of that just delays the progress of science.
To add to the other comments, everything you heard so far this morning about climate change is driven by data, and those data need to be collected. Equipment is not perfect, as we saw so far this morning, and someone needs to go out and fix equipment. There are various things that need to take place to make sure that you continue those data series. You can't make up data, that you can't go back and regenerate what you didn't collect. And so having these gaps where we don't have our critical federal employees taking care of collecting the data that we need so critically to provide the science you need to make informed decisions.
Thank you very much. Now, according to the IPCC special report, limiting global warming to 1.5 centigrade over the long term would, compared to 2, provide clear benefits to people and natural ecosystems. However, it would also require rapid, far-reaching, and unprecedented changes in all aspects of society. To achieve decarbonization of our economy, so for each panelist, if you would just comment, what are the potential costs of failing to limit warming to 1.5 centigrade? The witnesses can speak to their own areas of expertise in societal, economic, and environmental impacts. We can, yeah.
Well, I mean, there are a number of risks that accumulate the more carbon dioxide we put in. More heat waves lead to more mortality, as we've heard from our other speakers. Sea level rise will be somewhat higher, under 2 degrees versus 1.5 degrees, and so that leads to more coastal flooding. Both of those goals are heavy lifts, and so the most important thing to keep in mind, I would argue, is that to stabilize climate at any level, we need to get net global greenhouse gas emissions to 0. And I think it's important we recognize the more warming we let happen, the more the risk accumulate, but we've got to keep that goal as our centerpiece, net 0 global greenhouse gas emissions.
And I would just reiterate the fact that we are already seeing a large increase in the occurrence of extreme weather events, the intensity of many of those types of events, and that's only going to get worse as the globe continues to warm. And I just wanted to add also that it may seem arbitrary to pick a 1.5 or 2.0 degree warming of the Earth, but that's actually a very useful thing to do because we can use these very sophisticated climate models that have been developed by many groups over many years to simulate the kinds of extreme events and the kinds of changes in the physical climate system that would occur under both of those scenarios. They're very useful for helping us visualize what the world would look like under those two different kinds of conditions. And by doing that, we can see we really don't want a world with a 2-degree warming, and we certainly don't want to go past that. So it's a very useful exercise to go through visualizing these endpoints.
Yeah, I would echo my colleagues that the way I think about climate risk as we progress through these various temperature levels is the planet doesn't really care about it being 1.5 C or 2C, but the risks accumulate as we go higher and higher up through warming levels. The thing that jumped out to me as I was preparing for the hearing was the effect on coral reefs, funny enough. At 1.5 C, scientists are projecting that up to 90% of coral reefs globally will be substantially diminished by warming events. And at 2 C, that number goes to over 99%, which would be utterly devastating. So when we think about these global targets, we could really interpret those low temperature targets as being hedges, right? Looking to avoid catastrophic impacts on particular systems.
Another critical conclusion of the special report on warming of 1.5 is that it is possible to stay below 1.5 degrees C. And we can do that with current technologies. We have to increase our level of ambition. We have to be more proactive, but it's not impossible. So there is both the message that it's critical that we do so and that it's possible to make that commitment to stay below 1.5. And as the other speakers mentioned, as we increase from today, which is 1 degree above pre-industrial, to 1.5 to 2 degrees, that each unit of warming is associated with adverse consequences for our health, our livelihoods, our ecosystems, and for our economies.
Thank you very much. Before we proceed, I think we might have Dr. Mahowald ready for testimony. You may proceed.
Chairwoman Johnson, Ranking Member Lucas, and distinguished members of the committee, thank you for the opportunity to testify at today's hearing on the state of climate science and why it matters. I'd also like to thank the technical staff in the House and here at Cornell for making this happen. My name is Natalie Mahone. I'm a professor of atmospheric sciences at Cornell University with over 20 years research expertise in climate science. I'm here today to explain why climate science matters. And to put simply, it matters because the health and well-being of Americans matter, the U.S. economy matters, national security matters, and ensuring that the next generation of citizens can enjoy a better lifestyle than we do matters. Over the past year, we've witnessed record-breaking storms, precipitation, heat waves, fires and flooding, all of which show the power of weather and the potential for changes in climate to harm human lives and livelihoods. At the same time, we're witnessing a global revolution in the development of innovative new technologies that hold the promise of delivering a low-carbon emitting future. China and Europe, in particular, are investing heavily in these new technologies. The U.S. can take a leadership role in business, science, and technology to bring both clean energy and new jobs to thousands of Americans. These topics, climate change, its impacts, and the technologies to mitigate and adapt its effects, were the subject of the IPCC special report on limiting warming to 1.5 degrees Celsius, on which I was a lead author. This report comes at a critical time when we are rejecting the old-fashioned view that either we protect the environment or we promote business. The goal of the report is to identify solutions to reach low climate targets while promoting economic growth and eradicating poverty. Scientific evidence is clear that human activities have caused warming of 1.0 degrees Celsius since the late 1800s. If we keep warming at the same rate, we will pass 1.5 degrees Celsius around 2040. Past emissions alone, however, are unlikely to cause 1.5 degrees warming. In other words, if we can cut emissions quickly enough, we can arrest the Earth's warming trends, keep temperature below 1.5 degrees. This would require extremely ambitious emission cuts, 45% reduction in global emissions by 2030, which is much more ambitious than agreed to by the Paris Agreement and the voluntary reductions. In fact, the voluntary reductions agreed to through the Paris Agreement are likely to result in a warming of perhaps 3 degrees Celsius. While this falls short of the stated goals of the Paris Agreement, where governments agreed to keep warming below 2 degrees, it is much lower than the business-as-usual scenarios of up to 5 degrees increase in warming by 2100. The climate impacts will be lower at lower temperatures. Adaptation to climate change is easier at lower temperatures, but it's still going to be required. Whatever temperature target policymakers set as a goal, the 1.5 report provides a menu of policy options from which they can choose. This report also suggests an array of technologies and techniques across many sectors that may be deployed to strengthen the response to climate change. Combined, these policies, technologies, and techniques can help reduce climate change impacts either through mitigation or adaptation and are appropriate for any climate target. For example, reducing subsidies for fossil fuels or removing regulatory barriers for new energy-producing technologies and promoting a stable business environment and low-carbon technologies and techniques can create jobs, save money, improve health, and mitigate climate change. Promoting policies at the local, state, and federal level that move existing financing into new areas of research, development, and deployment for the energy, industry, transportation, agriculture, and building sectors can create new business opportunities and technologies while mitigating for climate. Finally, an important new area of research will be carbon dioxide removal and utilization technology. The world is very different today than it was 50 years ago in terms of how we live, how we interact with each other virtually and in person and globally. The world in 50 years will again be different, and the challenge of climate change will be one of the key ways that define our future in terms of mitigation and adaptation to climate change. Keeping America in a business and technological leadership role requires thoughtful investment in research, development, and deployment of innovative technologies and techniques that our international competitors are already investing in and will result in a more prosperous, healthier, safer America and world. Thank you for the opportunity to testify. I look forward to your questions.
Thank you very much. Now the chair recognizes Mr. Lucas.
Thank you, Chairwoman. I appreciate that. As I said in my opening statement, I represent a rural district where weather trends and predictions are extremely important to the agricultural community. Dr. Majkut, what are some of the things that we're doing well, and what are some of the things we could do better to increase preparedness for weather events and other effects associated with climate change?
Thank you for the question. I actually think we're doing fairly well. You look at the National Climate Assessment, and it shows a real effort on the part of the scientific community to start understanding what the medium and long-term effects of climate change are going to be for communities like your own. And so one of the things, and that activity should definitely continue. One of the things we might think about doing better, and the Science Committee and the Science Committee generally can think about doing, is getting decision makers information that's relevant on the timescales over which they make decisions, right? So you mentioned you represent a farming community and you're a farmer yourself. You understand that what you think about the weather is a question for the next few days and the stuff you're going to do over the next few days. It's not necessarily clear that a 30-year projection is a helpful thing for what you're deciding to do this year or next year. But if you're designing a water system or a stormwater system or something like that, something you want to have around for a long time, then you really do want to have information around what the next 30 or 50 or 100 years are plausibly going to look like. So I think the scientific community, you could fairly say, is learning how to do that, how to transfer that information, and how to make the kind of that whole range of timeframes from decade to decades to centuries available to people who need to think in that regard.
My fear from this increased demand for immediate action is pushed down from the top. perhaps unrealistic proposals that aren't practical. The last thing we want to do is to dramatically raise energy prices for America. Dr. Majkut, with the growing demand for fossil fuels worldwide, what can we do to ensure that we're leading the way with low-carbon energy solutions?
Well, in particular, I think the committee should continue to focus on and continue to be supportive of advanced research efforts for the things we think we're going to need in the future. And that means reliable, affordable, low-carbon energy. And in particular, low carbon is the key thing that the climate is worried about. So it doesn't particularly matter whether that's energy that's going to come from a windmill or a fancy kind of battery, or is going to come from fossil fuels with carbon capture and storage or advanced nuclear. Instead, the target should be having a broad array of energy sources that can be used here and abroad at affordable levels, and putting in place a research enterprise that is pursuing them with real vigor.
We make lots of investment in research in the federal government, and that's an important thing. How does the private sector advance what the government has started?
Well, the private sector is going to be the thing that actually scales those early run projects that receive justifiable government support into use, right? That's the thing that's going to matter in sub-Saharan Africa, it's going to matter in Southeast Asia, it's going to matter in Oklahoma. How do those things compete in a marketplace? And so making sure that those innovations diffuse out is a matter of transitional policies and market design.
From the back door of my house on the farm in western Oklahoma, I can see windmills, electric windmills, from one horizon to the other. Dr. Majkut, you have referenced or referred to the goals set by the Intergovernment Panel on Climate Change as ambitious. Is there a scenario in which those ambitious goals can be reached by transitioning to 100% renewable? By the way, those windmills don't always turn. They turn most of the time. We're a great source, but not all the time. Is there a scenario of how we could get to 100% renewable?
You could probably write one out on paper where it's physically possible, but I don't know that that's a necessary thing to do. And in particular, if like me and a lot of my colleagues and a lot of folks out there in the world, and your constituents are concerned about climate, and you want to reduce greenhouse gas emissions, having a broad portfolio of options seems like the best choice. And there is a raft of literature showing you that if you want a reliable, low-cost energy system that has a lot less carbon emissions than we have today, you want a wide variety of technologies available.
Thank you, Doc. Yield back the balance of my time, Madam Chairman.
Thank you very much, Mr. Lucas. Ms. Stevens?
Thank you all so much for bringing your expertise and time to today's hearing. We're privileged to be able to engage with you. Certainly on this topic, we have two choices. We can either embrace the need for climate change action and the embracing of climate science through fear, or we can embrace it through opportunity. And I am so grateful that Dr. Mahowald was able to bring her testimony to us through video. And my questions are for you, if we're able to ask questions of her. Are we able to do that? Okay, fabulous. So how are we as a country measuring up globally in terms of the actions that we are taking around federal investments to develop innovative technologies and solutions to address the impacts of climate change?
Thank you very much for the question. Are you hearing me? Good.
Yeah.
In the United States, it is starting to get the momentum to deal with climate change mitigation and adaptation. Much of the adaptation efforts, of course, have started at the local level, but they need to be moving across local, state, and federal levels. We need to be dealing more with the adaptation efforts for climate change, as well as mitigation across the board. At this point, the federal efforts have not been consistent with what needs to happen for the ambitious targets for climate change. And some of the states have been reacting much more ambitiously than others. And there's several studies suggesting that federal level coordination of the state's efforts is much more efficient for the whole system in terms of transitioning to lower carbon mitigation targets. Thank you.
Thank you. Well, I happen to represent suburban Metro Detroit, the home of the nation's automotive sector. And our automotive industry is in the race for the future, particularly around energy efficiency. And they see where China and Europe is moving, and they're sort of waiting on the United States. And so I was wondering if you could shed a little bit more light in terms of any projections that you might have that our country could capture in terms of a return on investment. Should we be making the right strategic investments to lay the foundation for our industrial sector to be making the investments in carbon neutrality?
Well, the transportation sector is an important sector, and of course, Detroit is the home of that in the United States. Our competitors are investing heavily in low carbon options. China is trying to get rid of internal combustion engines. India also has efforts in this area. The United States has the technological and the business innovation advantage. If we can use this, we can maintain our advantage in the automobile industry and other industries as well. But more coordination at the federal level, across the federal, state, and local level will really help in this effort. Thank you.
Thank you. I think it's fair to say that there's the if not but for role that government can play. Certainly, industry is making their investments, but they're waiting on the federal government to lay the foundation, set the table, as we have in many ways, where we created the highways and we plow fields, but we need to set the table. And I want to get Dr. Kopp in just quickly with my remaining time available, because you also mentioned this in your testimony, saying that climate change is not just an environmental challenge, it's an economic challenge, it's an infrastructure challenge, a public health challenge, and a national security challenge. And while we have your great expertise in the room, I was wondering if you could maybe give us a few points around how the U.S. can continue to be a leader in addressing the impacts of climate change while also maintaining our global economic power.
Well, I want to come back to the thing I said at the very end of my remarks, which is that we need to make climate change a routine and integrated part of decision-making, public and private sector, federal, state, and local. Right? We make lots of decisions, particularly when we think about, say, infrastructure investments, or particularly when we think about national security, that play out over decades. And anytime we're thinking about changes over decades, we're thinking about a world where the climate is changing in ways that we can project. And so we have to move beyond using the past as a guide to what we do. And when we're building a new rail tunnel under the Hudson, say, or we're building new water infrastructure, right? Those need to be planned with all of the range of possible futures that we might project in mind.
Yeah, thank you. I yield back the remainder of my time.
Thank you very much. Mr. Brooks.
Thank you, Madam Chairman. Dr. Kopp, I'm looking at your written testimony as opposed to your oral testimony. On page 3, you state, quote, "Climate change is real, it is here now, and humans are responsible for it," end quote. Is that an accurate statement of your quote?
Yes, it is.
And on page 5 of your written testimony, you state, quote, "Global average sea level has risen by about 8 inches since 1900, end quote, citing the Climate Science Special Report, Earth National Climate Assessment." Is that an accurate reading of that quote?
Yes, it is.
Are you familiar with the Earth's last glacial maximum, roughly 21,000 years ago?
Yes, I am.
And is it fair to say that sea levels during the last glacial maximum were roughly 400 feet lower than they are today?
Yes, it is.
And would it also be fair to say then that sea levels over the last 21,000 years, 400 divided by 21,000 or 210 centuries, sea levels have risen on average over that 21,000 year period of time at roughly 2 feet per century?
Well, it was concentrated in the first half of that time, but yes.
from the 21,000 to the 7,000 year ago period as a concentration, then it still increased, sea levels did, but at a much lower rate during the last 7,000 years?
When they stopped rising is a scientific uncertainty, but certainly that by 7,000 years ago, the giant ice sheet that was sitting in North America was gone, and so the contribution to sea level that came from that ice sheet ended.
So apparently, somewhere between 21,000 and 7,000 years ago, we had a very significant rise in sea levels, much more than the 2 feet per century average of the overall 21,000 year period. Did humans cause that?
No, they did not.
They did not. So there are other causes to sea level rises other than humans, and at least in this instance, of the last 21,000 years, we're looking at an average sea level rise of 2 feet per century, on average, 210 centuries, a little over 400 feet total. What was the cause of that?
Well, if you go back 21,000 years ago, my home state was sitting in its northern edges under about a mile of ice. And that ice sheet, which we call the Laurentide, had a whole lot of water locked up in it. And so as that ice melted, sea level rose. We're now in a very different world where there's the ice on the planet is largely almost exclusively in Antarctica and Greenland. And so what we're concerned about now.
Okay, I'm not asking what we're concerned about now. I'm asking what caused the 400 feet in sea level rise over the last 21,000 years. Would it be fair to say that it was global warming?
Yes, it would be.
And what is it that caused that global warming that began roughly 18 to 21,000 years ago?
So that we were in the ice age roughly 18,000 years ago, and the differences between the ice ages and the periods like we're in now, which are called interglacials because we're not in a glacial period, are paced by changes in Earth orbit amplified by changes in carbon dioxide.
Okay, so there have been fluctuations in orbit, perhaps changes in carbon dioxide, and perhaps also some change in the actual tilt.
Yeah, well, when I talk about changes in orbit on that frequency, you're talking about where Earth is pointing, what we call a precession.
Okay, and during the last glacial maximum, is it fair to say that almost all of Canada was uninhabitable, along with New England, New York, everything north of the Ohio River was in effect uninhabitable?
Certainly on the east side of the country, yes.
And would it also be fair to say that certainly, at least in that instance, global warming was a desirable thing if you're a Canadian?
Well, there weren't many Canadians, but yes.
Oh, there weren't any back then?
Over in the West there were, but yeah.
Okay. Now, let's talk about the remedy for a second. You may recall that in 2008, Dr. Stephen Chu, who later became President Obama's Secretary of Energy, stated that to combat climate change, quote, somehow we have to figure out how to boost the price of gasoline to the levels in Europe, end quote, which was about $8.70 per gallon. Do you agree with Stephen Chu that that is a remedy that the United States should implement?
Well, there's lots of policy solutions.
I'm just asking about this one, yes or no?
We are dumping CO2 into the atmosphere. One way of dealing with the problem would be to put a price on carbon that reflected the cost that carbon dioxide is imposing on the world.
Is that a yes or a no?
I'm going to give you the scientific answer and say, it depends. It's one of the solutions that would work.
All right, thank you, Madam Chairman. Appreciate the time.
Thank you. I'll now recognize Mr. Tonko.
Thank you, Madam Chairman, and I thank Chairwoman Johnson for holding what I think is a very important hearing today and for our witnesses for joining us. I am beyond excited that as a committee we are committing to seriously examining and addressing the urgent threat of climate change. I'm glad that this majority is focused on climate change and that we have stepped up to face the task at hand. And in particular, as a member of the Science Committee, I'm proud that after so many years of inaction, we're moving forward and giving this critical issue the time and focus it deserves and requires. Inaction is expensive. As we address climate change, our planning must be science-based and evidence-based. The overwhelmingly majority of the scientific community knows that climate change is happening and that we are already feeling the impacts. The scientific evidence on climate change clearly tells us that we need to take action. Taking action means there will be challenges, but also opportunities. We have a real opportunity to transform our economy to one that is cleaner, safer, and more just. We have the chance to advance clean energy technologies, design the infrastructure of the future that will help communities endure and rethink every industry we have ever known. Investing in solutions and resilience today will help manage and limit those risks and serve as a foundation for job creation, healthier communities, and economic opportunity. It has been a decade since the House last seriously attempted to address climate change. And with that, Dr. Mahowald, and I will address you as a fellow upstate New Yorker, and I know what weather can mean at this time of year. So we're sorry that you're not with us, but thank you for joining us via technology. So, Doctor, how has our understanding of climate science and its impacts developed over the past 10 years?
Thank you very much for the question and for your understanding of upstate New York's weather. Our understanding of climate science over the last 10 years has really benefited from the leaps in technology in terms of computer simulations, some of the big data analysis methods that we now have. And some of what that has allowed us to do is to really see the impacts of small changes in temperature on humans and ecosystems. And this was highlighted in the 1.5 report. Often what scientists do is we simply look at the big changes. But for this particular report, we were asked to look at the difference between 1.5 and 2 degrees, and we focused on that with almost 6,000 new studies were assessed in that report, and really focused on what small changes in temperature can do in terms of impacts on humans. And that report highlights that small temperature changes, for example, can have a big impact. Thank you.
Thank you very much. And when many talk about climate change, they associate the tone of urgency. Do you think there's more or less urgency than we faced a decade ago?
Thank you for the question. I think there's more urgency. Every day, there's more people on this planet asking for more energy, and we're building more facilities. And right now, the technologies that people use just by default is technologies that emit a lot of carbon dioxide. The faster we can start using research, developing, and deploying technologies that don't emit as much CO2, this can snowball into making it more and more economically feasible and politically feasible. All the infrastructure will be there to have lower carbon technologies deployed. So the urgency is twofold. It's both because we're accumulating the CO2 in the atmosphere, and in addition, we're accumulating infrastructure and technology that emits a lot of CO2. So there's a lot of urgency on the technology side. And then, of course, we're seeing more and more impacts on people. Thank you.
Thank you very much for your input and that of Cornell routinely on these issues. Dr. Ebi, according to both the IPCC special report and the NCA4, climate change takes a toll on mental health. Those who survive extreme weather events and see their communities damaged can suffer from depression, anxiety, suicidal thoughts, and post-traumatic stress disorder. The report notes that droughts have led to an increase in alcohol and drug use, and higher temperatures are associated with more aggressive behaviors. How does climate change affect mental health, and what steps can the medical community take to ease the psychological burden?
Thank you. That's an excellent summary of how climate change can affect mental health through exposure to extreme events. There needs to be increased awareness about this across the health professions so that there are greater actions when we have these extreme events, that we do have mental health care professionals available to help people after an event. And we need a lot greater preparedness for these events. If the U.S. was as prepared as it should be, we wouldn't have seen the impacts we've seen over the last couple of years. So investing in adaptation, investing in making sure we understand what future risks could look like, we're better able then to handle all of the challenges, including the mental health ones. Thank you.
Thank you very much. With that, I yield back, Madam Chair.
Thank you. I will now recognize Mr. Weber for 5 minutes.
I thank the gentlelady from Texas. Dr. Majkut, you mentioned that there's, quote, no better incentive force in the private sector, but if you really want energy innovation, you need to show the innovators there is a market waiting for them, end quote. Dr. Majkut, I ran an air conditioning company for 35 years, built it from the ground up. And I know that when the weather got hot, my business on the Gulf Coast of Texas was in great demand. I will tell you this, the more the Department of Energy raised energy ratings and required that manufacturers build higher efficient equipment, the more that those units cost, and the more the cost of air conditioning went up, the more the demand for that high efficient equipment went down, because people were already hard pressed living their lives and they couldn't afford higher prices. And on the Gulf Coast of Texas, you don't want to be without air conditioning. And I don't know how many of y'all live in the southern part of the country, but it's extremely important to us. Applying this same developing concept to clean energy technologies, Dr. Majkut, how do we show innovators that there is a demand and a market waiting for them?
Well, it depends on the area in which you're working, right?
Did I mention I live on the Gulf Coast of Texas?
Sure did, sir.
Yeah.
There's a lot of things government can do to create markets for innovation. A lot of them fall into other committees' jurisdiction, right? You can use tax policy, you can use incentive policies. I can't speak to the air conditioning example, largely because it's not my area of expertise, but I do know that we can look at cost-cutting measures. We can look at technological innovation to make more efficient air conditioners, as an example, less costly at the front. We can look at financing mechanisms that amortize maybe a more efficient air conditioner costs less to use over time. So how do you find ways to help people make an upfront capital investment, et cetera?
Okay, I'm going to move along a little bit. That's a great thought. Ranking Member Lucas said the push down from the top was the last thing we want to do because it would dramatically raise energy prices. And then there was some discussion between the witnesses with one of the members about raising those energy prices. Do we raise those energy prices to whatever it takes? I know, Dr. Kopp, you didn't have an exact price, but do we just commit to raising them to whatever it takes? Dr. Kopp?
Well, I'd say a number of the policy solutions you're talking about would raise the per unit energy price. But the idea behind trying to get the markets to work is that you wouldn't necessarily be raising the amount that people are spending on energy, because to take the air conditioning example that Dr. Majkut was talking about, right, cost a little bit more up front, just like solar costs a little bit more than a coal power plant up front.
But the question...
But you spend less over time.
Okay.
So a lot of these policies wouldn't necessarily increase total
Let me move down. So Dr. Francis, whatever price it takes to get to that point, is that kind of the philosophy here? Does it matter if we raise energy prices?
I don't think it's fair to say that whatever cost it takes, but I think we need to have a strategic plan.
Would you put a percentage on that, raise them 10%, 20%, 15%?
This is not, energy policy
Okay.
and economics is not in my field of expertise.
Fair enough.
But I feel that putting a higher price on energy
Let me
will do what we want it to do.
Let me jump over to Dr. Ibrahim. Any price, 10% more, 15% more?
The question is partially what's the price, but also how do you manage that? And is some of that price turned back?
Well, that's a growing technology, and we want America to be in the lead, American business and enterprise, right, to be in the lead for this. So, but I think there is a price where you make it so untenable for Americans that all of a sudden they kind of get turned off to the idea, and we don't want to do that. That's my point. Let me move on. Mr. Lucas said that in his state he's got lots of windmills, and I think you said you could see them from one horizon to the next. Have you ever noticed that on the hottest day of the year, the windmills aren't turning, and that's why it's the hottest day of the year? I mean, it's unbelievable that we can't rely on those. When it comes to national security, and you mentioned this, Dr. Kopp, actually in your comments, we're going to need a backup that our country can depend on, and it's going to have to be fossil fuel. I can tell you about requirements for energy. I'm working on nuclear energy capability. It needs to be at the table. It needs to be a major part of our portfolio. So we've got to take these things into account, and I appreciate y'all being here today, and I'm out of time, Ms. Fletcher.
Thank you. I'll now recognize Mr. Foster for 5 minutes.
Thank you, Madam Chair. And first, I'd like to thank Chairwoman Johnson for convening this important hearing. The climate challenges facing humanity are large, and unfortunately, serious debate on the best path forward has often been stifled by the politicization of this issue, at least in this committee. You know, for years, too often, we found ourselves wasting time arguing with non-technical witnesses about, for example, whether or not it's a matter of scientific debate, whether or not it would be a good thing if the Greenland ice sheet melted. So I was really thrilled to see some of the changes that appear to be occurring in this committee. You know, over the last several years, I have to say, on a personal note, I've grown truly tired of introducing myself as the only PhD natural scientist in the U.S. Congress. And to that end, I am thrilled to welcome onto the committee and into Congress Dr. Jim Baird as the second PhD natural scientist in the U.S. Congress. And I would also like to congratulate my Republican colleagues on their wisdom in appointing him as the ranking member of the Research Subcommittee. More to that point, I'd also like to thank Ranking Member Lucas and my Republican colleagues for selecting Dr. Majkut as their witness for this hearing. He's someone with a PhD in relevant science, and someone with views which are inside the scientific mainstream, and that's refreshing. You know, he's also someone, obviously, who understands that the question here is not whether or not this problem is real, but rather what is the most cost-effective way of solving it. And that is a refreshing change, because on this committee, we have to look deeply at the balance of research and policy spending to solve this problem. In terms of that, the best way forward, particularly the newer members on the committee, will be faced with just a mountain of things that have been written on this. And, you know, what I consider the best synthesis that I've seen was actually presented by former Energy Secretary Moniz in his testimony to the Senate last week. In a report that he highlighted by the Energy Futures Initiative, which he's one of the leaders on, entitled Advancing the Landscape of Clean Energy Innovation, really, to my mind, touches the main points of what knobs we should be operating in our government, both in terms of technological research, private sector efforts, and public-private partnerships to solve this problem. And so, I would at this point like to ask unanimous consent to enter into the record the report of the Energy Futures Initiative entitled Advancing the Landscape of the Clean Energy Innovation.
Without objection.
And so now I actually had one technical question for the entire panel. It seems to me that one of the changes in the last several years in the thinking on climate is the rising of the profile of methane as a significant greenhouse gas. That if you look at the impressive progress, apparent progress in the decarbonization of the U.S., a big part of that's by converting coal to natural gas use. And it now appears true that a large single-digit percentage of the methane that we burn actually gets vented directly to the atmosphere before combustion. And so if that is true, the fact that it's such a potent greenhouse gas really negates a lot of the progress in converting coal to natural gas. And apparently the technology to detect the thousands of small methane leaks is tough, and it's not going to be cheap. So I wonder if you had any thinking on what we do about the methane problem and where the research that could really make a difference there would be. We can just go down the line if you wanted.
Dr. Mahowald wants to. Yeah, I mean, I think we're sort of throwing money away and hurting the environment when you have natural gas leaks, and there has been a lot of discussion about how large those leaks are. There are all the incentives are there to try to solve those problems, and if it's not happening, that might be a good area for this committee to figure out how to push it along.
I think one of the difficulties I've heard pronounced is that it's simply, finding a very large number of small leaks is not cost-effective in terms of the savings in natural gas, and that's one of the things that makes it tough, at least with current technology.
So I would just like to bring up another issue related to methane, and that is the fact that the permafrost areas in the high Arctic are warming dramatically. We expect to see a lot more thawing happen. And when permafrost thaws, the biological material that's frozen in those soils can decompose then and become either methane or carbon dioxide. And we're seeing the warming happening much faster up there, in general, in the Arctic overall. And the loss of sea ice, which is a clear symptom of global warming, is contributing to the acceleration of that thawing of the permafrost. So this is another issue that I think we need to take very seriously, especially in the methane discussion.
Thank you. And it
Mr.
appears
Foster,
like-
your time has expired. I'd now like to recognize Mr. Babin.
Thank you, Madam Chair. Appreciate it. Thank you all for being here as expert witnesses. And we heard a little history a while ago. I had to leave the room for a minute, but I did catch the end of it. Very interesting, because I love history. Are you familiar, Dr. Kopp, with the Norse settlements in Iceland and Greenland, but around the year 1000, and that there was farming and animal husbandry in Greenland for nearly 300 years, which lasted up until about 1300, and then we had what we call the Little Ice Age, which lasted up till about 1700, and then the Greenland colony disappeared. But it's archaeologically sound evidence that has told us that it did last that long. What could have possibly caused the climate to change so much that we would have farming and animal husbandry in Greenland for a period of 2.5, 3 centuries? Could you have blamed that on human emissions, or can you give me an answer to that question?
So there are fluctuations that we see in circulation in the North Atlantic. There's something called the North Atlantic Oscillation that might have had a role to play there. The Little Ice Age, which was then triggered, may have had something to do with volcanic emissions. The details of that are still an area of research. A lot of that is more of a localized phenomena in the North Atlantic. There's some global temperature change, but that global temperature cooling actually starts around 1000 CE.
So we really don't, what you're saying is we don't really know. But in the opinion of everybody sitting at that table up there, was it more advantageous to have a little warming going on around the globe, or was it more advantageous to have a little cooling going around the globe? Because during the Little Ice Age, we lost lots and lots of humans to various causes that were in response and as a direct result of dropping temperatures. Well, how would you answer it?
Well,
I would say that it would be more advantageous to have lived in a climate that was a little bit warmer.
Yeah, so I would say that over that period, we are talking about a very small change in global temperature, roughly 0.3 degrees Fahrenheit. So it's worth keeping that in context when we're talking about the 2 degrees Fahrenheit, so almost 10 times as much that we've seen over the last century.
Anybody else want to answer that?
Yeah, Mr. Bevan, I think the way I think about it is not that there is an ideal temperature that we know for certain that human flourishing will be maximal. We don't that science can't really tell us that in a meaningful way. What we do know is we've built our society around the temperatures that we encountered over the last 200, 300 years. And as Dr. Kopp says, we're fixing to change those temperatures quite a bit. And that rapid transition is the cause for concern.
But we do know that when Canada and the upper part of the United States was uninhabitable during the Ice Age, that it certainly wouldn't have been conducive to economic development. I just feel like, there's no question that our climate is changing, no question whatsoever. But to blame and everything on human activity and expect the United States of America, the taxpayers in our country, to pick up the tab to pay carbon taxes and for carbon footprints and lower their quality of life and standard of living and increase the cost of living, while our biggest polluters around the world absolutely go scot-free and continue. So it's hard for me to justify how that we could be expected to pay that kind of a price. And I want to ask one more question, too. Do you support a transparent and full accounting of costs, benefits, and projected impacts to the global climate of individual climate policy proposals? I'm going to ask Dr. Ahey, is that the way you pronounce your name? I'm sorry.
That's fine. It's a difficult name, but thank you for the question.
Okay.
We do need a full accounting, and that does happen under the United Nations Framework Convention on Climate Change, at least in terms of emissions. And we know the U.S. alone is responsible for 25% of all emissions. There are efforts to try and understand better how much the cost of those emissions are in terms of impacts on our health, impacts on our ecosystems, our livelihoods, on our economies. And there's growing amount of work looking at what the benefits of action would be. Just from the health sector, we know that the health co-benefits of many mitigation policies are of the same order of magnitude as the cost of mitigation. That if we get more people to ride their bicycles, to walk to work, to change their diets, to have less exposure to particulates, the avoided premature deaths, the avoided hospitalizations are a very large amount of money that would offset the cost of emission reductions. So we do need to look much more broadly at the cost and the benefits, taking into account who bears the cost and who reaps the benefits, and how to make sure that this is done in a way that's as fair as possible.
But if we're responsible for 25% of the emissions, as you say, then why should we pay on nearly 100% of the cost? Because it sounds like that's kind of where that's the direction that you folks would have us go. And I think my time is over and expired. So
Yes, sir. I believe your time is expired.
Thank you.
Now, I actually am going to recognize myself for 5 minutes for questions, and I represent the western side of Houston in the greater Houston area along the Texas Gulf Coast, along with some of my colleagues on the panel. It is also the heart of the energy industry. And Dr. Francis mentioned Hurricane Harvey in her remarks this morning. Harvey, as we all know, is one of the most devastating disasters in our history. It was also our third 500-year storm in a span of less than 3 years. So we are seeing increased frequency and intensity of weather events. We are also seeing the risks of sea level rise and concerned about storm surge in our community. And in our district, we understand that climate change is real, and we believe in working together in a collaborative way is the best approach for us to tackle this challenge. That means collaboration between research institutions, industry, and governments at the federal, state, and local levels. So we believe that everyone has to be a part of the solution and a part of addressing this challenge. And with that in mind, I have a few questions relating to these topics. First, for Dr. Francis, can you tell us briefly what the science tells us now about the intensity of the extreme weather events that we've experienced and how that might or will change in the future?
Yes, thank you for the question. As I mentioned in my oral testimony, there are certain things that we know for sure are happening in the climate system. And Houston is probably in the crosshairs of a lot of those. You have seen, as you said, increased flooding. We know that heavy precipitation events are increasing dramatically. You've seen heat waves increasing. You've even seen drought increasing. And we also expect to see tropical storms intensifying more rapidly, and potentially we expect to see more of the very strongest tropical storms. A lot of those things are very clear. And what is a little less clear relates back to Harvey and some of the extreme events that you all have witnessed and experienced, and that is we're also seeing an increase in the persistence of weather regimes. So it could be dry, it could be hot, it could be cold, it could be wet. But we're seeing an increased persistence, and we believe that that is also related to climate change.
Thank you very much. And more broadly for the panel, we do believe it's important to include everyone in working together on these solutions. So in particular, do any of you all have experience with or suggestions on how the energy industry can work together with your institutions and with those of us who are making policy to be part of the solution towards climate mitigation? And I should also add, I believe that they already are, and certainly in my district, most of the industries have acknowledged and are working to combat climate change. But any specific ideas you have of policies or programs you think would be helpful for this committee to know?
Well, so there's sort of a style of doing science that I think very much gets at this, and that's science that is sort of stakeholder engaging, and the jargon is transdisciplinary, but basically the idea is start with a problem, right? The problem is the resilience of the energy system off of Houston. And then you're going to get together the different disciplines that you need to address it. You're going to get together stakeholders, and you're going to do the research together in a partnership. And that's a very different style of doing research than what's traditionally happened in universities. And I think it really needs we need to be rethinking a little bit of that part of the climate science enterprise to sort of make this more of a problem-focused thing.
Thank you. Dr. Eby?
Thank you. It's a very good question, and I want to echo that working with stakeholders is critically important in this process. And to step back more broadly and say that companies want to have healthy workers and healthy communities. They don't want to see their workers flooded. They don't want to see the impacts on their workers and on their families. And so there are ways that one can work together to try and ensure the resilience of the community while the companies work to ensure their own resilience, to make sure that as these extreme events occur, they are not affected, that their facilities are not affected. So facilitating those partnerships at the federal, state, and local level is critically important.
Thank you very much. My time has expired, so I will yield back the remainder and now recognize Mr. Baird for 5 minutes.
Thank you, Madam Chair, and this is my first congressional committee hearing, so I hope you'll excuse me if I make any procedural errors, and I prefer you not express those to me. I'll just take that for granted. But anyway, I'm honored to be here in that capacity and to be able to have the discussion that we're having today about climate change. I do appreciate my colleague, Dr. Foster, for those kind words. But as a farmer and an animal scientist, I know the importance of leaving the land healthier than what we found it for our next generation. I've got grandchildren, and I think it's important to those children and grandchildren. And so the health of the land has always been a concern for agriculture people, and that is important to our ability to feed ourselves. But in that vein, I'm also recognize that the natural evolution process over time, the tremendous ability of mammalian tissue or mammals and plant tissue to adapt to their environment. I don't see much discussion about that in some of the presentations, but I do find your presentations extremely interesting and very insightful. I would like to just point out a couple of things. Dr. Eby, not picking on you in any particular reason, but for example, we mentioned 729 children died from heat stroke from 1990 to 2014. So I guess my question there is that because the automobiles were better, they had, or the children are less exposed to their environment than we have in previous centuries and so on? So I think we need to take those kind of factors in when we make those predictions about the impact of the climate on some of the issues we're concerned about. For example, the elderly, are we older as a generation, so are we becoming more susceptible as we age? And so compared to 50 years ago, we're living a lot longer. And so those are just things that if you want to respond to that, you're welcome to. It was really more of a comment than anything, but I'll give you that option.
Well, thank you, and thank you for those comments. And I do have a couple of short responses. On the evolution, the climate now is changing faster than it's been in 10,000 years. And so it is a challenge for many of our plants and other species to try and evolve fast enough in the face of this rapid rate of change. In terms of the children dying in cars, the data were only collected over a certain period, so we don't have data from before then. But the point is, as temperatures are going up and we're seeing more heat waves, we're seeing higher temperatures in summer, people don't realize how quickly cars heat up. And so it's terribly unfortunate how many infants are dying in cars because people don't realize, as they say, I'm only going to be gone for a minute, that minute may be too much for an infant in the higher temperatures we're experiencing now.
I really understand that and can appreciate that, and I think that's a tremendous mistake that parents make in doing. But my question comes back to, is that because the cars are tighter, the windshields are better, the glass heats up more, and so on? No excuse for leaving those children. And I don't want to comment about that. That's okay. We're okay there. But I do have some questions for Dr. Majkut. You know, in the developing field of technology, the United States, I think we ought to be a leader in that because we have the ability and the talent to do it. We have the research capability. So my question to you is, are we behind other countries in our developing a cleaner environment, cleaner energy sources?
It's a tough question to answer. I think the answer probably varies on exactly where you answer. I think in bulk, no. The U.S. research enterprise is really strong. We provide a lot of resources to that enterprise. And if you look at environmental performance, not just on climate, but on other issues over the last decades, we're doing pretty well.
So would it be fair to say that our country makes a lot more investments in cleaner energy sources than another country around the world in terms of reducing our pollution, even though we use a lot of the fossil fuels?
Don't know. Don't know the relative spending, sorry.
Okay, then how about, you know, agriculture is extremely important, as I expressed. It's extremely important to my district. And so we have Purdue University in the area, and Dr. Dukes has also provided some assessment of what the climate change has on agriculture, but it can impact growing seasons, plant growth, animals, and some of the things that's already been discussed. But so, what do you think? What do you think we ought to be doing right now to correct these areas? What are some of the things you think we might be able to do relatively rapidly?
On farming specifically?
The gentleman's time has expired.
All these procedures, I tell you. Thank you very much.
I now recognize Mr. Barra. Dr. Barra.
Thank you, Chairwoman Fletcher. You look good in that chair, by the way. You know, first off, it is glad that we're kicking off this Congress and this committee with a hearing on climate science, on climate change, and you know, really taking a look at what we can do to try to mitigate this. And you know, you will hear aspirational goals. You know, you can call them whatever you want, if it's a Green New Deal or something. But aspirational goals are not things that we should shy away from as the United States. You know, if we look at our own legacy and our own history, going back to the throughout our history, but you know, recent history in the '60s when President Kennedy challenged us to go to the moon, we had no idea how we were going to do it. It was an aspirational goal, but we put all of our intellect, industry into that, and we accomplished it. And we accomplished it faster than the president challenged us. So let's not be afraid of setting these aspirational goals. And we know from going to the moon and the whole Apollo program, it was economically sound as well, because we can think about all the industries and innovation and discovery that came from that. I'm proud to be a Californian. I'm a lifelong Californian. And in our state, we did pass legislation recently that moves us to the goal of 100% clean energy by 2045. That is an aspirational goal. But we also know we're the 5th largest economy in the world. It hasn't stifled our economy. In fact, there's over 500,000 clean and renewable energy jobs in California, and that's growing. So again, we don't have to be afraid of setting those goals. Dr. Kopp, I think you mentioned getting to that goal of net zero global greenhouse gas emissions. I think that's an aspirational goal, but let's set that goal out there, and then let's work towards it and use our innovation and intellect to get there. I've got, from a science perspective and a question, and I'll let all the witnesses comment on this. There's also the issue of the carbon that is already sequestered in our atmosphere. And, from the scientific perspective, what are the things, we're not talking about mitigating future emissions, but are there ideas out there for us to degrade the carbon that already is up there that is trapped? Sure, whoever wants. Go
I'm
ahead.
happy to speak if I'm able.
Yeah, please.
The removal of carbon dioxide from the atmosphere is innovative new technologies are moving in this direction, and we do need more investment in this type of research, development, and deployment of these technologies. There are some sectors that are going to be very difficult to cut the CO2 emissions from. And removing carbon dioxide from the atmosphere is a very good method of reducing climate risk at the same time as we are working to mitigate as well as adapt in other areas. So, for example, if you want to sequester more carbon in agricultural soils, this not only reduces the carbon dioxide in the atmosphere, it also makes the agricultural soils more resilient to climate change, as an example. But there's 2 recent National Academies reports on how to look at carbon dioxide removal, and I think it's an area that the United States should invest more research and set up the business environment to allow companies to invest more in. Thank you.
Great, thank you. Dr. Kopp?
Yeah, just to add on to that, there's a wide range of approaches you can take, from expanding forests, which is slow, but we know works, to a variety of technological approaches that, as I said in my opening remarks, are sort of new and untested. I think one thing to keep in mind is that the amount of warming we have is roughly proportional to all the CO2 we've emitted. So if we want to reverse warming by removing CO2 from the atmosphere, we're going to have to talk about building infrastructure that's of a scale comparable to that we're currently using to put CO2 into the atmosphere. Right? So the first use of these technologies are going to be, as Dr. Mahowald mentioned, for areas where it's hard to get the CO2 out. But if we want to talk about reversing climate change, we're talking about huge growth of this area using technologies that are still really to be developed.
Right. Any last comments, please?
One last comment to go to what you said at the beginning. I'm at a very large state university, and students are so excited about the possibilities of working in this area. Students want to contribute to the solutions, they want the training, so that they can be part of this transition that we're going to undergo.
So it's a lot like those of us who were growing up in the 60s during the space race. It's inspiring, and let's not be afraid of setting those aspirational goals. I'll yield back.
Thank you. And before we move on to our next questions, I would like to enter into the record without objection a consensus letter to Congress from 31 nonpartisan scientific societies that acknowledge and affirm human contributions to climate change and notes the severity of climate change impacts is increasing and is expected to increase substantially in the coming decades. With that, I recognize Mr. Waltz for 5 minutes.
Thank you, Madam Chairman. So, my district's in Northeast Florida. I grew up on Florida beaches. The seas are rising. Anyone who's grown up there knows that the beach is smaller than when I was a child. I just don't see how that's disputable. But I do want America to lead this effort. We've led the world in coal, oil, and gas development. Now we need to do it with rapidly growing clean energy markets. I think to succeed, we need a very broad portfolio of emphasis here, low-cost technologies to speed the transition to renewable, cleaner energy. I think that includes nuclear. Undeniably, I would caution my colleagues. We have seen a lot of aspirational goals lately. I think we need to be very careful about crossing the line from aspirational to outlandish goals that could harm our economy and frankly give the edge to our global competitors in doing so and frankly take us backwards in this effort. So I'm very concerned as a veteran as well about the national security implications of global warming. I have firsthand seen and unfortunately could not count the amount of soldiers that have died carrying diesel fuel back and forth to outposts that we could have sustained through clean technologies. I've seen, not to mention our global supply chains, and not to mention I've spent a lot of time in Africa, Lake Chad Basin, where we're dealing with the destabilizing effects in Nigeria, Niger, what have you. So my question for each of the panelists is, what R&D, Dr., did I say this right, Majkut? Mica, excuse me. You said we're doing pretty well in our investments, particularly relative to the rest of the world. My question for each of you is where are we not across the kind of menu of clean energy technologies? Where do we need to do more? And again, keeping this in the context of our broader economic base that I think we need to sustain all of these efforts. So where could we do more? Geothermal, and I'd ask you to choose. The answer can't be yes, all of the above.
Let me say first, we could be doing more, right? Like the scale of the challenge and a lot of the concerns that your colleagues point out about increasing costs with present-day technologies to reduce greenhouse gas emissions, those are real and valid concerns. And in particular, you can't expect these things to scale unless the prices at which they're trading are competitive. Mm-hmm. So on the whole, doing more is not necessarily a bad thing, and then doing more smartly is probably the thing that the committee should really pay attention to. So the places where, when I read these IPCC reports or the National Climate Assessment or these other documents, the places where it seems like the technology hasn't caught up with the need, carbon capture and storage is one, right? This allows us to use fossil fuels for power generation and take advantage of all of their desirable characteristics without emitting greenhouse gases.
To make it more cost-effective or just to do it?
In large part, simply to do it. There are very few facilities at which this is happening.
Just in the interest of time, I mean, my understanding is the majority of our dams in the United States do not generate electricity. Nuclear accounts for about 1/5 of the United States electrical generation right now. And then, of course, we're seeing just a boom in natural gas and where we can go with that. Would you agree that those are all areas where we could make greater investments that would make a difference on this issue?
Yes.
Would any of the other panelists want to weigh in on either of those questions?
Thank you. So I'm from Massachusetts, and in Massachusetts, we've had incentives for solar energy for about a decade now, and many roofs have solar panels on them. To put a solar array on your roof now, the payback period is about 6 years before you start basically making money on your investment. It saddens me to fly over your state, frankly, because I look down and I see almost no roofs with solar panels on them, and you're just missing a huge opportunity. And yes, it took some incentives to get the ball rolling down the hill, but now the incentives in Massachusetts are disappearing, and still people are putting solar on their roofs.
I would point out that in Samsula, Florida, Florida Power and Light has a 1,200 solar facility. It's estimated to provide electricity to 14,000 homes, 30 million solar panels by 2030, but I'm sure we could all collectively do more. Those are state incentives, to be clear, at the state level or local level.
Yes.
Thank you so much. I yield my time.
Thank you. I now recognize Ms. Bonamici for 5 minutes.
Thank you very much, Madam Chairwoman. I want to thank Chairwoman Johnson and Ranking Member Lucas for holding this hearing, and I also wanted to take just a moment to say congratulations to the Environment Subcommittee Chair Representative Fletcher and wish her a very happy birthday. Thank you.
Thank you.
So thank you to the witnesses for being here today. You know, the science is clear. I've been on this committee the entire time I've been in Congress. We've had this conversation many times. This consequences of inaction on climate change will be serious and swift. The findings of the recent report from the International Panel on Climate Change, the IPCC, and the fourth National Climate Assessment are not just a wake-up call, they are an alarm. At the time when the world is facing record heat waves, droughts, more acidic oceans, rising sea levels, and a surge in extreme weather patterns, we must fight for comprehensive policies to protect the health of our oceans and our planet. I was concerned when the Trump administration appeared to be burying the fourth National Climate Assessment. They released it on late on a holiday weekend. So I shared findings from the assessment on Twitter every day for 6 weeks to call attention to the assessment. When the president dismissed the findings in a Washington Post interview last year, I worked with my colleague on this committee, Mr. Beyer. We led 96 of our colleagues in urging the president to heed the dire warning of the assessment and work with us to protect the health of our planet. The assessment is the most comprehensive science-based evaluation of the consequences of climate change, the risks of inaction, and potential adaptation strategies for the United States to date. We cannot and should not dismiss its findings. Dr. Ivey, according to the Air Quality Chapter, Volume 2 of the assessment, more than 100 million people in the United States live in communities where air pollution exceeds health-based air quality standards. Climate change will increase the risk of unhealthy air quality. How are children, older adults, low-income individuals, communities of color, and those experiencing discrimination disproportionately affected by climate change? And what can we do to mitigate the health consequences of climate change for these vulnerable populations?
Thank you for the question, and this is a very serious concern, that there are people who are differentially exposed to poor air quality. It's from particulate matter, it's from ozone, and it's also from things like pollen. And so people in the groups that you mentioned often live in communities that have much higher exposure. And it's an opportunity, going back to the question we had a few minutes ago, of looking at issues like energy efficiency to make sure that we reduce how much comes out of our tailpipes so that people don't have so much exposure. I will note that the United States cannot sell cars in China because we cannot meet their emission standards. So there's lots of opportunities to reduce emissions. Reduce emissions also from coal-fired power plants is incredibly important to protect people's health. Thank you.
Thank you. We also save healthcare costs when we do that, obviously. Dr. Kopp, I noticed in your written testimony, there's a sentence that you have in there about, in 1990, President George H.W. Bush signed the Global Warming Response Act of 1990. I just want to note that that was a long time ago, and we still need to respond. The Coastal Effects chapter of Volume 2 of the Fourth National Climate Assessment states that 13.1 million people are potentially at risk of needing to migrate because of sea level rise by the year 2100, creating drastic consequences for socially and economically marginalized and low-income groups. In your testimony, you discuss how climate change is an infrastructure challenge. We're having a lot of infrastructure conversations here on the Hill. What infrastructure investments and strategies should Congress address now to prepare for rising sea levels and avoid catastrophic damage?
Well, of course, that's a complicated question because infrastructure is fundamentally local. And so the answer is going to differ depending on where you are. The fundamental thing is if you're building infrastructure that's going to be around for 80 years, like it is foolish not to take into account changing climate conditions and changing sea level rise for that period, and know when you build that, what you're going to do if it turns out we're on a relatively low sea level rise course, and what we're going to do if it turns out we're on a relatively high sea level rise course. We don't know yet, because it depends both on ice sheet physics that are still being studied and on greenhouse gas emissions that we haven't emitted yet, whether we're going to see 2 feet of sea level rise over the course of this century or more than 6 feet. And those have very different implications. And so we need to be thinking about how we can build flexibility into our designs and coupling the infrastructure designs and deployment to the science that will tell us that information as soon as it can.
Thank you very much, Madam Chairwoman, and I am just about out of time, so I'll yield back.
Thank you. I'll now recognize Mr. Norman for 5 minutes.
I want to thank the panel for taking the time. Mr. Mica, I think what's been said here, and I'll ask all the panel, this country's, and I'm from South Carolina, I'm a real estate developer. Is the figures right? We are 20%, we contribute 20% to emissions as opposed to other countries.
If I'm correct, it's slightly less than that, maybe 15, 16, but ballpark, it's right.
Okay. And I've heard the other comments that that everybody needs to pay. How do we, if we're 16%, pick a figure, how will we make the other 82% pay their fair share?
So, like, first of all, we can generate a lot of innovative technologies here in the United States using our research enterprise that are exportable. We can share that knowledge through formal arrangements or informal ones, or simply through exports. We can also demonstrate, using a variety of policy instruments, that it is possible to have a thriving economy and a healthy society with lower greenhouse gas emissions, and we can export those models as well.
Okay. Any of the other panelists have any comments on that?
I'd be happy to come in.
Yes, ma'am.
The other thing to recognize with this very good question is that under the Paris Agreement, countries have voluntarily agreed to cut emissions, and people have evaluated the cost of these and the relative cost to gross domestic product. And actually, the United States voluntary contribution is actually quite low compared to its GDP. So other countries are volunteering to do more than their fair share. Thank you.
If that's the case, then it's really apparent now we need to put a price tag on, prioritize and put a price tag. Is that right? On what this is going to cost, like the green energy deal that's we're probably going to vote on. It's a non-binding resolution. But before we go doing away with flatulent cows, airplanes, we need to put a price on it, don't we?
Yeah, from a public policy perspective, we should always be cognizant of the costs and benefits of the choices we're making, and try to be judicious in moving forward, seeking low-cost options.
Yeah, in my world, you you find your goal, put a price tag on it, and then move from there. And I think everyone would agree this is going to cost dollars. It's going to cost it, and I think Dr. Kopp, you wouldn't put a figure on how much we're going to have to pay for gas, but it's going to be more expensive than what we've been paying. Is that right?
Yeah, so I think certainly the upfront cost of energy will go up, but average costs may go down. And I think it's really important that when we look at the costs, we're looking at the cost of climate change in comparison. There's a lot of economic work going on to try to evaluate those two, and these have to be balanced against
Have to
one
be
another.
balanced. And would it not be fair with the increased costs, whatever figure we end up, you're going to rule out some of those most vulnerable communities that are not going to have access to energy, as an example. And now, what kind of cost would that be to them on their health, through PSD, through their mental health? How would we put a number on that?
Well, I mean, I think the intent is not to overly punish any particular class of people or any particular technology. It's to put in place a system that we all are going to benefit from in the long term. And that means that for day-to-day activities that people are going about, and that they're able to do that in a low-carbon way, great. What we need to do as a society is find ways that doesn't end up being too costly. And frankly, I don't know that it is going to be too costly. It's just a matter of making smart investments, leading the way to innovation, and then scaling those up through the private sector.
Dr. Mica, if as an example, this Green New Deal were implemented immediately, wouldn't you agree it's going to devastate our economy, and other countries are going to take up the practices that we're eliminating, as in the cows that they grow, the other areas that we are going to have to, they will make the difference up in this, even though we don't.
Yeah, and in fact, the Green New Deal is a moving target. It's not sure what it is, but based on my understanding from the resolution that's been introduced, as well as the things that have been said by its primary backers, the decarbonization, that is reducing the CO2 associated with economic activity, is one of the cheapest elements of the Green New Deal.
Thank you so much. I'm out of time. I yield back.
Thank you. The chair will now recognize Mr. McNerney for 5 minutes.
I thank the chair and I thank the witnesses this morning. Natural gas sounds great compared to coal, but the more effectiveness of natural gas in reflecting infrared radiation compared to carbon dioxide means that if just 2% of the produced gas escapes into the atmosphere, the efficiency benefit over coal is lost. Does anyone on the panel disagree with that? No? Does anyone want to make a remark about that? Okay, thank you.
I could say some.
Sure, go ahead.
Well, thank you for the question. One of the differences between methane and carbon dioxide is how long they reside in the atmosphere. So in the short term, methane can be very bad for the climate as well as for air quality. Most of the impacts of methane are actually on air quality. But methane only lasts about 10 years in the atmosphere, whereas carbon dioxide, 20 to 30% of it is going to last centuries to thousands of years. So in terms of trying to solve the really big climate problem, we should focus on CO2. Methane is a big problem for air quality especially, and a little bit for climate, but we should try to mitigate the methane as much as possible. But it is actually lucrative to capture, so it's a much easier target.
That's a good point. We need to capture it rather than...
That it's actually economically feasible to capture much more methane if people were careful about it.
Thank you. Dr. Knopp, how can positive feedback loops accelerate climate change?
Well, positive feedback loops are sort of a core part of how the climate system works. So to take one example, if we put more CO2 into the atmosphere, that causes some amount of the warming. It causes melting of ice in the Arctic. It makes the Arctic less reflective, so that causes more warming. When we talk about, say, tipping points in the climate system, which is language I don't love, but is used, all of those tipping points are driven by positive feedbacks, having to do with things like, for instance, ice sheet-ocean interactions leading to rapid loss of the Antarctic ice sheet.
Good. Dr. Eli, briefly, would you identify some research that the federal government should be engaged in on climate change that's not doing right now?
Thank you for the question. There are so many opportunities to increase the research enterprise in this area. I'll speak specifically for health. There is almost no federal research dollars going into research on the health impacts of a changing climate and how we can adapt more effectively to that. So any kind of investment would be very beneficial for the health of Americans and for our healthcare infrastructure.
Thank you. Dr. Knopp, I understand that most or all climate models underestimate or even grossly underestimate the rate of climate change. Do you agree with that?
So I think what you're referring to is a statement in the climate assessment looking at the ability of climate models to reproduce past warm periods. And there's definitely a systematic tendency of climate models, if we compare them to the geological record, not to produce as much warming as we see evidenced in the geological record.
Well, given the state that we're in, that the climate effects we're seeing now are due to carbon dioxide that was introduced in the atmosphere decades ago. Do you think we can avoid a 1.5 degree C increase by just reducing carbon emissions alone?
I think the 1.5 degree C report tells us it is possible physically, but it may be challenging. Right? If we have to get greenhouse gas emissions to net zero very quickly if we want to do that.
Well, I think because of that, we need to expand our research into climate intervention. And not that I want to go there, but given that 1.5 degree change is almost inevitable, and 2 degree change is likely, in my opinion. We need to understand the tools that would be available to avoid catastrophic change if it comes to that. Would you comment on that?
Yeah, so I think it's very clear it would be very helpful to have more effective technologies for removing carbon dioxide from the atmosphere. So that's one category of climate intervention. There's another category that has to do with putting pollution in the stratosphere to make the planet more reflective, and I think that needs a lot of careful analysis to see what the risks are and whether that would be feasible from both a technological and policy perspective.
Right, so we need to do research in order to understand what the risks and what the potential benefits of that would be.
Yes.
Thank you. I yield back.
Thank you. The chair will now recognize Mr. Gonzalez for 5 minutes.
Thank you, Madam Chair. Thank you to everybody for being here. As a newly elected member of Congress, I just want to mention first how excited I am to serve with everyone on this committee and look forward to working on bipartisan solutions that will make the American people proud. So I believe that climate change is real and global industrial development is a contributing factor. I also believe that my first responsibility and my unyielding loyalty is to the hardworking men and women of Ohio's 16th District and the economy that allows us to heat our homes, fuel our vehicles, and build our businesses. As I look at the most recent proposal, the Green New Deal, I cannot help but believe that this would put a tremendous burden on my community. My community is proud of our blue-collar roots. We are proud of the products we make, the crops we farm, and the jobs that we hold. Simply put, the Green New Deal would threaten all of that. And we only really need to look to Germany and their what I'll call Green New Deal Light for an example. Since 2000, Germany has spent an estimated 189 billion euros, or about $222 billion, in renewable energy projects, while emissions have been stuck at roughly 2009 levels and even rose recently. According to the Wall Street Journal, taxes and rising power generation costs have made Germany's electric rates the highest in Europe. In sum, they spent a lot of money, raised taxes and energy prices, and nothing really happened. The proponents of the Green New Deal are proud to admit that their plan represents a fundamental remaking of America's economy. They believe in a system that relies on a near full government takeover of some of our most important industries to solve our most pressing problems. With Germany's example and common sense as our guide, we simply know that this will not work. But it's not enough to point fingers. As I said, this is real. We do have a problem, and the government can play a role in helping solve it. What I believe is the most reasonable path forward is a path that does not focus on a federal takeover of our economy, but rather a path that fosters a diverse set of energy sources and seeks to make alternative energy as affordable and reliable as the traditional sources we use today. And for that, I do not wish to rely on government takeovers of our biggest industries, but rather I want to focus on empowering the American people and unleashing the most powerful economic force in human history. If we do this, then we will be able to reduce carbon emissions at home, but also abroad, as we are able to commercialize these to-be-developed technologies and sell them around the world. And best of all, we will do that without having to ask my community to pay a very steep price. With that, Dr. Majkut, could you comment briefly on the extent to which this is a global issue versus one we can solve on our own? And based on your understanding of global development patterns, specifically in China, India, and Africa, how feasible and realistic is it to exclude fossil fuels from all sources of energy globally?
Thank you for the question. I think you've really hit the nail on the head, right? The science tells you it's a global issue. Atmosphere doesn't care where carbon dioxide molecules come from. They have the same warming effect no matter where their source was combusted, if it's a fossil fuel source. What the U.S. can do is work to innovate the technologies we believe we'll need to have not just an economy similar to today's, but one that's much larger globally, and finding smart ways to make sure those technologies make it to market. And that's an advanced research agenda, that's kind of industrial policies, and it's market and finance design questions.
Okay. And then cost is obviously very important, and I think we focus a lot on that, which is right. But when I speak to our manufacturers, one of the issues that they talk about a lot is reliability of the grid. So if we were to switch to these technologies, the renewable technologies today exclusively, we turn the new Green New Deal on today, would we even be able to manufacture? Would our manufacturers be able to rely on the grid as it's currently constructed?
I don't think so, no. It seems like the lights would go off. But that doesn't mean that you couldn't change over the course of a few decades, which is what we're trying to do.
Right. And then my last question, and I hate these up or down ones, so I apologize, but when you think about the Green New Deal as you've seen it, and I know the details need to be fleshed out, do you believe that is a realistic path forward?
No, sir. I think it's a broad progressive agenda greenwashed by some climate details.
Thank you. Yield back the balance of my time.
Thank you. The chair will now recognize Mr. Cohen for 5 minutes.
Thank you, Madam Chair. Firstly, I believe the new Green Deal is aspirational, and I think it's important that it puts attention on the dangers to our planet at this time and the urgency of our actions. Some of the specifics certainly aren't going to happen anytime soon. Some of them will probably never happen at all. But the concept of putting people's minds and attentions to climate change is very important. Does anybody disagree that it's not an important matter to inform the public of the urgency of the changes that will occur to our planet? Thank you. That's why I'm a sponsor of the bill, because it brings attention to the issue. It's getting warmer and warmer, hotter and hotter, more violent weather, hurricanes because of the warming oceans and currents, and rising levels of sea level are endangering what we've known. I've read that Miami Beach could very easily be underwater and oftentimes has water on Collins Avenue that they have to pump. I think we ought to concentrate on is Mar-a-Lago. What are the climate consequences to Mar-a-Lago if we don't act? Can anybody give me an idea about how long it might be before the oceans rise to a level to where Mar-a-Lago might be underwater?
So I don't recall exactly how high Mar-a-Lago is.
Depends on the night and who's sponsoring the party. I understand.
But we can, we could be looking at sea level rise anywhere between 2 and 6 feet, and I think in the century, depending partially, as I said, on ice sheet physics and partially on how much CO2 we put into the atmosphere. And my suspicion, because I have actually looked at this before, I just don't recall the details, is that certainly under those higher scenarios, you might be looking at permanent floodings to start with some of that property.
What if this happens 2 to 6 feet? And I know it's decades and whatever, but they're going to be generations of people to be Mar-a-Lagites. What if they built a big seawall, a big, beautiful seawall at Mar-a-Lago? Would that do any good against the ocean?
So the challenge in South Florida is that a lot of it is limestone that is porous. And so that means that the ocean water isn't just coming from the side, it's coming from underneath. So it's sort of hard to protect South Florida only with seawalls.
That's kind of like El Chapo. He came from underneath, he came from over, so the walls wouldn't do any good there either. People have talked, the gentleman from South Carolina talked about the cost of all this and their cost to doing things with industry, but there are tremendous costs if we don't do anything. The air conditioning bill at Mar-a-Lago would have to go up as it gets hotter and hotter and hotter. Has anybody done a study on the dollar cost, the fiscal cost to business if we don't take action?
We're part of a collaboration called the Climate Impact Lab, together with University of Chicago, Berkeley, and Rhodium Group. And those are exactly the sort of questions we are working on. We're still working towards some of that. But the approach we use is sort of to look at things like, for instance, how different years in the past have led to different air conditioning expenditures, to take the energy sector as an example, and how that varies based on how hot it is usually and how wealthy people are, and use that to project forward. So this is a really cutting edge area in climate research, we're sort of working towards using big data approaches to answer those sorts of questions.
So a lot of the issues that'll arise, like the use of more air conditioning, really militates against poor people because they won't have air conditioning at all often or can't afford the utilities, and so they bear the brunt of climate change in a larger, greater way than wealthy people. There's a climate change burden.
Yeah, I mean, so generally what you find is that the poor suffer and the rich can spend to adapt. So they both bear costs, but in some cases it's more personal costs, suffering, and the others is more monetary.
And somebody mentioned, which I pretty much understand, if we correct certain issues here and reduce our production of CO2, that if it doesn't happen in the rest of the world, we still got problems. But isn't the best way to do that the Paris Climate Accords or some climate accords? Does anybody disagree with the fact that we ought to have a climate treaty where we come together and have an accord? We're all in agreement on that? Kumbaya. Thank you, and I yield back.
Thank you. The chair will now recognize Mr. Cloud for 5 minutes.
Thank you, Madam Chair, and may I again wish you happy birthday. Thank you all for being here. Mr. Majkut, at the beginning of your written testimony, you say that there's no better innovative force than the private sector, but if you really want energy innovation, you need to show innovators that there's a market waiting for them. Can you speak to what recommendations you would encourage for energy innovation in the market?
Sure. I think a lot of things are already in place showing energy innovators that there's market access for them. Paris Climate Agreement is a great example, right? A lot of countries are saying they want to reduce greenhouse gas emissions, and that incentivizes people to innovate ways of doing it. Speaking kind of more at a U.S. national level, I think there's a lot of things that could be done on the fiscal side, whether that's a carbon price or smarter regulations than we have today to create a competitive marketplace. There are intermediate steps that can be taken when things aren't quite ready to scale into the market. A good example of that would be the 45Q tax credits that are presently offered for producers or people who capture carbon and sequester it or use it in some manner at new facilities. That gives you your first few. And then on the back end, there is the scientific and engineering enterprise, which reduces the cost of doing all of this.
Thank you. I hail from Texas, specifically the 27th District of Texas, it's Gulf Coast. My district includes nuclear power. We have the #1 energy exporting port in the nation. We have wind energy. We have LNG, crude exports. Very diverse as far as an energy portfolio is concerned. Texas is a leader in that, also a leader in wind energy, and just having, generally speaking, a diverse portfolio. The Green New Deal, however, seeks to limit that to specifically non-carbon produced energy in the next 10 years. Is that feasible without crippling innovation and economy? Or do you think that with new technologies, fossil fuels could play a part going forward?
Two things. One, I'm not a big fan of timetables generally. I think we know enough that we should be trying to bring low carbon technology to market, setting super ambitious goals. I understand the impulse. I totally agree, but I think you can kind of get in your own way. And where we find ourselves today, that's a very ambitious goal for where we've been. I think the climate doesn't particularly care where energy comes from so long as it's not emitting CO2, and that means that there are a lot of reasons why you'd want to pursue a diverse innovation portfolio.
You say the climate doesn't necessarily care where emissions come from. In a sense, too, the market doesn't care where the energy source comes from. And the appetite globally for energy is growing. And it seems like one can make the case in the sense that we've now become a leading exporter of energy to the world, which is, in essence, creating stability in the world. People are able to buy energy from us instead of countries that hate us. U.S. companies generally also are more likely to care about being good stewards of creation, so to speak, than other energy-producing nations. Could the case be made that this continued progress in this sort of realm would actually have more of a beneficial environmental effect going down the line?
Yeah, if I interpret you correctly, I think so. Generally, U.S. practices are at the higher end on lots of environmental compliance issues. It also means, freely available low carbon energy is the thing that's going to power the 21st century and make everybody better off.
Could you also speak to how important a thriving economy is to creating innovative solutions?
It's totally essential. What we seek at the Niskanen Center, what I think is best for this issue, is an economy that's flexible to new information, that can provides routes for people to finance new projects and find profits where they can make them. And then generally we want those, as long as those are low carbon options, everybody gets better off. That's exactly what we're looking to achieve.
Thank you. I yield my 4 seconds back.
Thank you. The chair will now recognize Mr. Kasten for 5 minutes.
Thank you. Look, there is no greater threat to our economic well-being, our national security, and even our survival as a species than climate change. And I want to thank Chair Bernice Johnson for taking it seriously, making it a priority of this committee meeting. And I want to thank all of our guests today for your implicit acknowledgement that while we have the authority in this room to debate and ultimately change the laws of the United States, we have no such authority when it comes to the laws of thermodynamics. So thank you. I'd like to address my first question to Dr. Francis. I represent the 6th District of Illinois. We recently experienced a rather extreme cold snap. And, as I think you know, and we appreciate, these extreme low temperatures have in fact been attributed counterintuitively to warming in the Arctic that disrupts the Gulf Stream. And yet we have a president who seems to think that a cold snap in one location disproves global warming. Could you please educate us on how global warming in aggregate can lead to periodic polar vortex events in the United States?
Yes, thank you very much. It's not a simple story, and it's an emerging science research question, although the science has been progressing very rapidly in this particular connection between what's happening in the far north with weather patterns more generally, and particular with these extreme cold events in the winter. And what we're learning is that there's a region in the Arctic just north of western Russia where sea ice has been disappearing probably faster than anywhere else. And that particular location is special in the sense that when we lose ice in that area, it absorbs a lot of extra heat from the sun, which then gets returned to the atmosphere, and it tends to create a pattern in the jet stream that can then influence the true polar vortex, which is much higher up in the atmosphere. When these conditions all align, it can topple, if you will, the polar vortex, which is a spinning river of air around this pool of cold air that sits over the Arctic in the wintertime. And when it's a powerful enough punch to that polar vortex, it can cause it to deform or even split into different circulations. And that's exactly what happened this past winter that brought you a new record cold temperature for Illinois. One of these pools of cold air from the Arctic drifted down over North America and reinforced the cold air that's already there during the wintertime. So this connection back to sea ice loss is the climate change connection, because that sea ice is disappearing because of global warming.
Thank you. While Illinois has seen an increase in extremely cold weather, we're also seeing an increase in extreme heat events. We saw it back in 1995 with the great heat wave in Chicago. A lot of the focus has been on urban impacts. There was a recent 2017 study on environmental health that analyzed heat waves in Illinois and found that there were actually significantly higher increases in hospitalizations per capita in rural areas. And with the consent of the chair, I'd like to ask unanimous consent to enter the study into the record.
Without objection.
Thank you. My next question is for Dr. Mahowald. The cost of inaction on climate change is high, but over the last 2 decades, we've seen costs of renewable technologies fall, lots more opportunities for energy efficiency, and at least some initial decoupling of economic growth from CO2 emissions. This is frankly not that surprising to me, I don't think, nor to the business community, because I think we all recognize that when we buy less fossil fuel, we actually save money, and we have a little bit more money in our pocket, notwithstanding some earlier conversations about air conditioner economics. If you invest a little bit more capital today to save a lot of money later, that's a good thing. Dr. Mahowald, you had mentioned in your testimony that limiting warming can, in fact, go hand in hand with increasing economic prosperity, which I hope means that you agree with the points that I just made. I would welcome your thoughts on some of the policy changes you would encourage us to take up that would both lower CO2 emissions and incentivize more investment in the United States and economic growth.
Well, thank you for the question. I want to be honest here. I'm actually a physical science expert, but I will talk a little bit about what the special report from 1.5 has to say on this issue. The important thing that we looked at in this report is where one can cut emissions in the most economic way that also has benefits locally, for example, on air quality, or ways that you can change people's behavior that makes them healthier as well as addresses climate change. For example, if Americans and Europeans actually ate the amount of meat and dairy that their doctors recommend they do, they would be healthier. In addition, this would cut emissions of greenhouse gases. So there are a lot of ways that you would save money because you're healthier. Humans would be better off. Americans and Europeans would be better off in all ways, less hospital visits, feel healthier. And at the same time, we're trying to address climate change. So there's quite a bit in the report where there's benefits from climate mitigation that we can feel right now. In addition, just the switch in some policies to make it easier for businesses in these innovative new sectors to have a stable business environment. I mean, what's happening in the United States now is the fragmentation a little bit, as some states are more aggressive than others. And so at the federal level, it would help trade within the United States if there was a little more leveling of the terrain. But overall, there are a multitude of policies and techniques and technologies that are proposed in the special report on 1.5 that each individual state and local government, as well as the federal government, should evaluate that can make it so that it is economically beneficial to address climate change. Thank you.
Thank you, and I yield back my negative 1 minute, 30 seconds of time.
Thank you. The chair will now recognize Mr. McAdams for 5 minutes. Oh, I'm sorry.
Thank you.
I'm sorry, Mr. McAdams.
Yes.
I didn't see Mr. Marshall.
Okay.
I didn't see that you were sitting, hadn't gone. I'm sorry. The chair will now recognize Mr. Marshall for 5 minutes, and then Mr. McAdams.
Okay. Thank you, Madam Chairwoman. Let me make my first official words as ranking member is to wish you a happy birthday as well. And I'm looking beside me here. I was going to ask all the members to join me in singing happy birthday. So the people in the audience are going to have to help me here, Lizzie, okay? Happy birthday to you. Happy birthday to you. Happy birthday, dear Lizzie. Happy birthday to you.
Thank you very much.
You're welcome.
Your 5 minutes can begin now.
Okay. All right. Well, I want to just take a second and focus on innovation. I'm a physician. I think innovation has done more to improve healthcare probably than anything I can think of, and has the potential to drive the cost of healthcare down more than any legislation that we can write up here. And I think of some of the great learning institutions, research institutions in Kansas, Kansas State University, Kansas University, Wichita State University. So, Dr. Majkut, let me ask you, if I'm going to go back, I'm going to be visiting with my leaders in those universities, what would you be telling them to think about for innovation, for research, and where do you see us going? Just give you some free rope here and chat a little bit.
I'm sure I would have a lot of ideas to share with them. I think we have a good grapple on the nature of this issue, and we have a good sense of kind of what it is that we still need, right? renewable energy is a topic we talked a little bit about today. It's doing well. It's market competitive in a lot of cases, but it's intermittent, right? Not just because like the sun doesn't shine at night, but sometimes, you're over the space of months or years, you're going to get different weather patterns, and that's going to affect things. So really what we need to think about are what are the characteristics in energy sources that we want going forward that we don't already have. So that might be easily dispatchable, very resilient, low-carbon energy sources, for example. Identify those. Understand where you can find the most scale, both here in the United States and internationally, and pursue them with speed and vigor.
Okay. I think about innovation across the country, fracking, some of those types of things are opportunities, carbon capture. Would you suggest us developing innovation here to help other countries? Do you think we should just send money to other countries to help them do things?
I think we should focus on innovation. All of our policies should be, at least as a side benefit, incentivize people to innovate new ways of doing things, because what we really want is for people to do a lot more globally while emitting a lot less, and that's an innovation challenge primarily.
Okay. Well, what's the coolest innovation thing out there that we haven't talked about today?
Oh, that's interesting. Energy storage, the idea that we can find lots of interesting ways, either through mechanical or chemical means, to store a lot of energy is a very I think, an interesting thing. My favorite example is very large flywheels like you have in the clutch of your car. You can, when you have excess energy, spin them up, and when you need to take energy out of the storage system, you generate it from this massive spinning wheel.
Okay.
I don't know that that's being deployed, but it's a great idea.
Okay, thank you so much. I yield back.
Thank you. I'll now recognize Mr. McAdams for 5 minutes.
I was going to sing happy birthday to you. You beat me to it. So, thank you, Madam Chair, and happy to be here for this hearing and for putting climate science at the top of our committee's priorities for this Congress. I think it's an important issue for the entire Congress, and happy to see us taking it up here on the Science Committee as well. Thank you to our witnesses for your providing your expert testimony and really enlightening this conversation. I'm excited to join this committee and to have an opportunity to understand the latest in climate research and highlight its importance in shaping our policies that will result in clean air, better environmental health, and a clean energy economy. As the former mayor of Salt Lake County, a county in Utah that often sees school kids kept inside for recess because the air's not safe to breathe, I have 4 kids myself, and was shocked to learn that part of their common vocabulary is, it's an air day, meaning they don't play outside at recess. They come home bouncing off the walls because they've been kept inside all day. I know how important it is that we address our winter inversions in Utah, our summer ozone pollution, but while climate change is certainly real and important to us as to our global, to us as the planet, it's also very important locally, and the impacts that we feel locally vary from place to place, but we see it locally even in Utah. I know how important imperative is for Utah families to apply sound science to the solutions that we seek. Utah remains the youngest state in the country, and numerous studies document the risk to pregnant mothers, to their newborns, and to those with respiratory problems such as asthma when they're exposed to dirty air. We've long been aware of the harm to older adults with heart and lung ailments as well, even the likelihood of premature death. Utah is keenly aware of the economic costs of climate change as well. When the Wasatch Mountains are not visible due to smog, our ability to sell our region to, a region where tourism is an important part of our economy, ability to sell our region to a new lifestyle-oriented businesses, it's greatly diminished. Utah's had its share of environmental issues as well, devastating environmental issues, from last summer's catastrophic wildfires to extended drought to the shortening of a ski season. First world problems, I recognize, but it does have an impact on us when snow melt comes late and melts early. We also In a desert area, much of our watershed is captured and stored in the form of snowfall. And then as snow melts, we have reservoirs. But as we have less snowfall and more rainfall, the ways in which over the last couple of centuries we've adapted to living in a desert will not be adequate as climate patterns change, and will be expensive for us. We can adapt, fortunately, unlike some places, we can adapt, but it will be expensive to us locally. So I think Utahns support efforts to protect our air, to protect our water, to protect our quality of life that we experience in our Rocky Mountains. And in fact, our early pioneer settlers in Utah understood that in an arid landscape, water is life itself. And anything that threatens the climate threatens our ability to sustain life over the long term. As elected leaders, we have the capacity and the responsibility to have fact-based discussions about the issues of climate and environmental protection. And it is critical to our nation's goals for environmental sustainability, for economic prosperity, and our national security. So I believe that hearings such as the one today shows that we are serious about protecting health and spurring innovation to address the challenges that we face to transition to a clean energy economy. And I'm proud to be here and to be part of the solution. I'm looking forward to working with this committee to advance solutions to our climate crisis and to jumpstart, as I've said, a clean energy economy. So my questions, I guess I'm almost out of time. So my first question, and maybe my only question, is to Dr. Eby. The fourth National Climate Assessment explains how the health of vulnerable populations, such as older adults and children, will be disproportionately affected by climate change. What are investments in research, not only technology research, but also research to the health and other areas of research should we make to further identify, to mitigate, and maybe even remedy these risks?
Thank you for the question. It is such an important issue. As I mentioned before, the total federal investment in this area is really incredibly small. A review by the Office of Management and Budget several years ago said the NIH budget in this area is less than 0.02% of the budget, and it's likely fallen since then. CDC gets a little bit of money to work with communities. So what we're seeing are communities who are disadvantaged and don't have access to those who can help them. They don't have access to the research. Very few departments of health have access to the kinds of tools that they need. And we've got enormous opportunities to build on the research enterprise to improve the health of Americans right now. And it would be excellent if that investment would take place so that that could start soon.
Thank you. Thank you, Madam Chair.
Thank you. Next, we'll hear from Ms. Hill for 5 minutes.
Thank you, Madam Chair. So to our guests, I want to thank you so much for your testimony, and I apologize for jumping between hearings this morning. But based on what I've heard so far, my impression is that in this Congress, we should focus on setting the stage and laying the groundwork for the next 20 to 30 years of addressing this issue. I'm hearing that we should focus on research, on infrastructure, on regulation, on public and private partnerships, and on global partnerships and leadership. And I'm wondering from you if you can kind of talk, this question's to all of you, about in each of those areas, what are just the biggest gaps, what the biggest gaps in research where we need to prioritize, the highest priority when it comes to infrastructures. We're working on an infrastructure package. The biggest concern or need when it comes to regulation, the most significant impact we can have in terms of corporate incentives related to the public-private partnerships, and when it comes to the role of foreign policy on global partnerships and leadership. I realize those are a lot of questions, but pick the area you want to focus on and then just give it to me.
So quickly, because I want everybody to have some time, I agree with all of the things you raised. One thing I think we need to think about is that this is a multi-generational challenge. So as we make the investments today, and I'm going to talk about the research enterprise, we need to think about, well, how are we building the research enterprise to help us deal with the fact that this is a problem that's not going away. It's a chronic problem. And so I would argue we need to be investing in something comparable to the agricultural extension program in our country, where we have networks of researchers deployed throughout the country who serve as bridges from the research community to the people on the ground and help build those partnerships and sustain them so that they're not dependent upon a grant here or there or a personality here or there, but we're really building the sustainable research infrastructure to build a link between the science and the people making adaptation and mitigation decisions on the ground.
And maybe just a little more specifically, more related to my field, would be some research priorities, perhaps, that this country has fallen behind, in my opinion, in terms of model development for climate modeling, and I think this is one of our primary tools for understanding what our future holds based on different scenarios for the future. And also seasonal forecast models, so understanding how the climate change is going to affect weather patterns, so not so much what the weather's going to be tomorrow, but getting a bigger lead time in weather patterns that will affect agriculture, which we talked about earlier, and other aspects to infrastructure, that sort of thing.
I think on the advanced research side, focusing on having a portfolio of options available. This problem looks a lot different today than it did 10 years ago. I think we can reasonably expect it to look pretty different 10 years from now. And we want to leave our future policymakers, or when you're all much more senior, a lot of options on the table. I think that's a really important thing because the scale of the change that will be needed to meet the goals in these reports is substantial, not impossible, but it's substantial.
Well, and I think for you in particular, Doctor, I was curious about your thoughts on the public-private partnerships and the corporate incentives that we might be able to put into place.
I personally, and as an institution, we institutionally see a fairly limited role for public-private partnerships. Largely, I think we should be focusing more on market design, and particularly we support carbon tax in lieu of regulatory approaches, which we presently have.
Okay.
I'll add an issue that hasn't been raised is multidisciplinarity. We've talked about a whole range of risks of a changing climate. Those all interact. They don't happen at once, they happen together. We're seeing heat waves and wildfires. And so making sure that we have the partnerships not only with our stakeholders, but across the scientific community, which requires different thinking about how we conduct our research, and frankly, then how universities are organized to do that research. And so there does need to be significant incentives to move from disciplinary-based focus to a much broader focus of how we can collectively put together our wisdom, working with the knowledge from our stakeholders to come up with the innovative solutions that we need.
Thank you.
If I can speak?
Can't quite hear. Yeah. I'm looking at the TV. I have no idea if you know that I'm talking.
No, I can see it, but thank you for the question. I just want to mention also the area of carbon dioxide removal. We not only need to be working on mitigation and adaptation, but this new area of carbon dioxide removal, there's a lot of potential in this area, and there's very little research money being put into this so far from the federal government, for example, or for companies. So this is a new area that could also be very beneficial for reducing climate risk in the future.
Thank you so much. Do any of you have anything to add in the last 30 seconds? Great. Thank you so much. I yield back.
Thank you. The chair will now recognize Mr. Lipinski for 5 minutes.
Thank you, Madam Chair. I was just speaking at Introduce a Girl Engineering Day event, and I was saying we need everyone that we can get on board to work on the solutions to the big problems that we face. And I mentioned specifically climate change being one of these major problems where we're going to need all the work that all the best minds and brightest to figure out how we move to a clean energy economy. One thing I think that we can do a good job at is, from the government side, is putting more funding into ARPA-E to help move some of these, get some of these innovations developed, move forward. But another thing that I have been supportive of, and 10 years ago, I actually introduced the first bipartisan carbon fee bill that was introduced, where all the money would go back to the public, fully refunded carbon fee. So I want to ask Dr. Majkut, you just briefly mentioned it. Why do you think that that would be a especially good way to approach this issue?
3 reasons. The first is when you take a direct run at the problem, which is greenhouse gas emissions, you are hopefully finding the lowest cost option. That way, you're not playing favorites, renewables versus carbon capture and storage versus nuclear, and you're not pre-committing to things. Rather, decision makers throughout the country, whether they are engineers at ExxonMobil or utility executives, are making decisions to favor low carbon options, and all their efforts add up relatively quickly. So there's a strong cost effectiveness and a strong efficacy argument there. The other reason is, or the second reason is that insofar as this is a question of how do we get affordable, reliable, low carbon energy out at scale, mechanisms like carbon pricing are the easiest way to achieve scale incentives for all those decision makers I just mentioned. And the third is, I think, importantly, the signal that comes from there being congressional intent on climate change for problems of these timescales, decades, is very important. It provides a lot of certainty for economic firms out in the world, both here and abroad, that the U.S. is moving in a particular direction. And in the environment we have now, we don't have that.
Thank you. Some of the questions have focused on, well, what is going to be the negative economic consequences from doing something on climate change. I want to focus from a scientific standpoint on what are the consequences to the U.S. economy that if we fail to address this and slow the rise of greenhouse gases. What do you think of what would you worry about the most? So who wants to start? Dr. Kopp?
Sure. Thank you. So we actually had a paper out on that a couple years ago, and we looked at several different types of impacts. The two that floated to the top were both public health impacts, so the effects on mortality and the effects on the ability of people to work outdoors. Both have quite large economic impacts. We also see economic impacts associated with the stresses that warmer temperatures put on the energy system. We see economic impacts from the damages that storms cause to the coast. We see economic impacts from the effects of warmer temperatures on agriculture. And those are just the sort of sectors where we can sort of look at past behavior and say something about the future. We also have a fair bit of concern about the things that we haven't observed yet in the past but might cause risk. So when we start having more extreme events happening simultaneously, that's a potentially large impact that's harder to assess.
Thank you. Anyone else want to put anything? Dr. Francis?
So just to follow up on that a little bit, we know that in 2018, the losses due to extreme weather were roughly $160 billion just to the United States. And the year before, 2017, they were up around $300 billion. So we're not talking about small numbers here. But I think what keeps me up at night is thinking about my own daughter and the world that she's going to face if we do nothing. And for me, the scariest thing is thinking about the security issues overseas and how people are going to be more miserable and therefore more unhappy. And we're going to be dealing with a lot more migration and wars that are the result of people just being very unhappy in their situation.
Well, it's very sobering, but I think it's a good way to end on that concern as we work on moving forward to solve this. I'll yield back. Thank you.
Thank you. Before we bring the hearing to a close, I want to thank our witnesses for being here today and testifying before the committee. The record will remain open for 2 weeks for additional statements for the members and for any additional questions the committee may want to ask of the witnesses. The witnesses are excused and the hearing is now adjourned.